ऑलरेडी स्टार्टेड जॉइनिंग।
नहीं, इसका सेटिंग कहाँ है?
क्या सेटिंग?
एडमिट नहीं करना पड़ेगा ना?
नहीं, वो ऑलरेडी मैं म्यूटेड रखा था सबको।
नहीं, म्यूटेड तो ठीक है।
हेलो। हेलो। हेलो आ रहा है आवाज?
हेलो ओके
नहीं आ रहा है।
आपके आवाज
हेलो हेलो you speak me something. You can unmute.
हेलो am I audible? You are muted. मेरे ख्याल से सिग्नल चला गया है इसमें. You are muted. Hello am I audible?
No, you are audible, ma'am.
Okay thank you sir. Vinay Sona is raising hand. क्या हो गया? एक विनय को बना दो पोस्टर. Chat this. Okay. Zoom group chat. There is some buffer sign. Buffering. Some kind of buffering is there. Always do. Recording is on.
The speaker is
Dr. Prashant Gupta is there. Makes her co-host.
आप कुछ बात करिए।
Hello, Prashant sir. Good morning. Unmute करो. तो दिखता है. प्रशांत गुप्ता सर.
You making course, no?
Yes, madam. Good morning.
Good morning, sir. How are you, sir?
Yeah, I'm good, madam. How are you?
Fine, sir.
Great, great.
Sir, can we start, sir?
I guess we'll wait for madam and
Okay,
then
okay.
we'll go ahead. Yeah.
Okay, sir.
Just a small question. Do we have only faculties as the audience here?
No, sir, we have students also, sir.
The students are there as well. Okay.
Yes,
Yeah.
sir.
So I can orient. Yeah, I can orient the talk based on who is the audience. Fine.
Okay, sir.
Yeah. Ruchi madam.
Yes, sir.
Abhilasha madam has also joined. So please
Okay.
unmute her mic. Yeah.
Okay, okay. Sir.
Hello, good morning, ma'am.
Good morning. ma'am. Good morning.
Hello, good morning, ma'am.
Hi, good morning, ma'am.
Good morning, Abhilasha, ma'am.
Yeah, good morning, ma'am. How are you?
It's not there. क्या मैसेज आ रहा है? अभिलाषा मैम नहीं आई क्या?
Yeah, she is there.
Ma'am, I'm here.
मेघा अभिलाषा मैम को होस्ट में.
View पे चलते हैं।
अच्छा. I should. Okay. Hello, ma'am.
Yeah, hello, ma'am. Can you hear me?
Yes, she can hear you, but
something actually
cannot
कुछ
see you. Just 1 minute, ma'am.
Okay, otherwise I will log out
कुछ
and then
blocking
once
blocking
again I
है
will
ऐसा,
enter.
continuation.
No, it's not problem with you, ma'am. Just
Okay.
just give us 1 minute. No, she logged out. Logged out.
नहीं ना
It is there.
Not responding.
No, it isn't. So she is there.
Yeah, she's there.
Please, no. इसका थोड़ा चेंज करें.
हाँ, अच्छा आप क्लिक करो ना.
Ma'am, shall we start, ma'am? Bless you, ma'am.
Yeah, can you hear me? Am I audible?
Yeah, I can. Yes, ma'am, you are audible.
Yes, we can start, sir. If everything is ready, we can start.
Yeah. No, shall we start? Yes, yes. A very good morning to all. I hope I'm audible.
Yeah.
Yes, sir. Please go ahead.
Yeah. A very good morning all. On behalf of Jabalpur Engineering College, Jabalpur, I myself, Dr. Kodam Yugandhar, an assistant professor in the Department of Applied Physics, Jabalpur Engineering College, Jabalpur, welcome you all for this one-day virtual labs hands-on outreach workshop. Okay, so let's start the session with Pradhana. Just let me share my screen. May I around?
आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदाम् जाड्यान्धकारापहाम् हस्ते स्फाटिकमालिकां विदधतीम् पद्मासने संस्थिताम् वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Now, I welcome the head Department of Applied Physics and the regional coordinator of Nodal coordinator of Jabalpur Engineering College, Jabalpur, Dr. Ruchi Nigam Madam, to say a few words about the today's virtual labs hands-on outreach workshop. Over to you, ma'am.
Good morning to all of you. On the behalf of Jabalpur Engineering College, I welcome you all, especially Daroha sir, Dr. Abhilasha ma'am, and Prashant Gupta sir, and all my dear participants. Actually, there is a very pandemic period. In this pandemic period, I welcome you on the behalf of Jabalpur Engineering College. Basically, Jabalpur Engineering College or JEC Jabalpur is previously known as the Government Engineering College or GEC Jabalpur and was established on 7 July 1947. It is one of the oldest technical institutes in India and the oldest technical institute in the central India and the state of Madhya Pradesh. And the college is affiliated to the Rajiv Gandhi Technical University, Bhopal. The college was declared autonomous in 98 by the government of Madhya Pradesh. The JEC offers BE degree or BTech degree in 7 disciplines and 9 postgraduate courses in engineering fields, 3 postgraduate courses in applied sciences and MCA. All the departments of JEC has been rendering excellent teaching since the inception of the institute, imparting the knowledge. The present one-day workshop on virtual labs, hands-on outreach workshop, a program under Atmanirbhar Madhya Pradesh and as a part of tuning activity with WCE Sangli is designed for faculties and students to encourage, conduct and perform the lab experiments. Also, the workshop aims at the conducting the activities regarding the propagating VLabs uses and the outreach uses. The benefit of workshop are, as we know that there are several benefits of this workshop, and the main benefits of these workshops are real looking of components to give the user a feel of real laboratory, a step-by-step wizard to guide the students through the experiment, and repeat the experiments with various other conditions. And The main and important point of the virtual lab is that it is available for 27/7, so the students can learn difficult concepts at their own pace. Okay. Now, at this point, I will say only one thing, that is good luck to all of you and happy learning. Thank you, Kodam sir. Please, Kodam sir, proceed.
Thank you, ma'am. Now I request the principal, Professor Arvind Kumar, to give say a few words about the work. We have already recorded. I am going to share it.
Today, the session on virtual lab hand-on outreach workshop with the help of IIT Mumbai, IIT Bombay, and JEC Jabalpur. I think all the students are benefited by this hand-on training, and it is for all the faculty, all the students, for all the branches. So the eminent speakers from Aurangabad and IIT Mumbai also help how they use the virtual platform for their practical classes. So definitely all the student is benefited by this program. Thank you. Thank you very much.
Thank you, sir. I hope, am I audible?
Yes.
Yes, one minute. Okay. Now, I request Dr. Santosh, sir, Principal Investigator, Virtual Lab, IIT Bombay, to talk about, give about virtual labs. Before that, I would like to, it's my privilege to introduce Dr. Santosh, sir. He is the Principal Investigator of Virtual Labs at IIT Bombay. Dr. Santosh Narayana sir is working as a professor at Department of Chemical Engineering, IIT Bombay. He has been at IIT Bombay since 2001. He did his Bachelor of Technology in Chemical Engineering from IIT Madras and PhD from UMBC. He was then employed as a postdoctoral fellow for several years at NIH. He is an expert in the research field, namely recombinant biotechnology, computational biology, etc. He has published more than 70 research articles in various reputed journals. He has published 8 books to his name, 2 book chapters. He has also several patents to his credit. He is a biochemical engineer by training who has evolved multidisciplinary interest. He has focused on understanding various metabolic and regulatory aspects of microbiological systems towards rationally manipulating their productivity using genetic engineering techniques for various production of therapeutics. Among other activities, he has focused on reactor optimization strategies for bioprocesses and developing algorithms for online adaptive control. This has resulted in an open source, indigenously developed bioreactor platform. This focus on indigenous instrumentation has extended into the creation of low-cost virtual laboratory rigs as well as healthcare devices. He coordinates the development and deployment of virtual labs and MHRD ICT project. He is also professor in charge of the Tata Center for Technology and Design, an interdisciplinary center with a focus on creating solutions with high social impact, and coordinator of the Healthcare Research Consortium at IIT Bombay, which interfaces with major hospitals and research labs in the Mumbai area, and is now actively engaged in translating several collaborative research efforts into technologies. Over to you, sir. He has already shared his presentation. Just give me 1 second to share his presentation. Am I audible?
Yes, sir.
Voice is not coming.
Yeah, video is not audible, sir.
One minute. I'll be right back.
Primordial. So, as was indicated, Virtual Labs is a program funded by the Ministry of Human Resources, and it's been something which is a counterpart to NPTEL, which all of you, I'm sure, are familiar with. So, the intent has been that between NPTEL and a collection of interactive simulators called Virtual Labs, that there be enough free content available to students across the country so that they can self-learn. And there is a long-term vision that MHRD has of creating an online open university for which there has to be high-quality content, which is both created but maintained. So before I get into the nitty-gritties of Virtual Lab, we actually need to step back and think about what the reasons we actually carry out lab experiments, especially in an engineering university context. There are two broad reasons to my mind as to why a good experiment works, and that's basically because you're either testing a theoretical concept or else you're being made familiar with some real-world hardware. So look at the first point there. There's theory that's usually taught to us in some theory course, but invariably we end up seeing the counterpart of that as a lab experiment much later in our whole academic program. We typically at IIT Bombay see that corresponding lab experiment 1 semester after a theory concept is taught. The problem with that is there's no immediate reinforcement of learning when that theory is taught. In an ideal context, you learn a bit of theory and you immediately test it out in some interactive fashion, ideally at some physical apparatus. And if you can't do that, then you do it at a interactive simulator. But the moment you do these things side by side, you are in a situation where your learning has gone to a different level because you have essentially reinforced applicable those theoretical concepts are. The other scenario is that of training engineers to move out into the real world and play around with real world hardware. And most of us will acknowledge that the lab experiments that we run in our typical of various kinds, which allow for people to play on collects of money. The things that we play around with are not real world systems. So we play with very robust lab systems, given that large numbers of students have to, as batches, undertake these experiments. In some situations, like for example, with the training of pilots or surgeons, there's just no ability to do real lab experiments all the time. You can't be, for example, surgeons cannot be practicing on patients or even cadavers all the time, which is where you need simulators. And those simulators, on the other hand, have to be very realistic and designed. So you'll realize that most of the physical labs that we undertake as part of our regular curriculum don't address either of these two things in good fashion. And when the virtual labs program was started by MHRD, it was to test out various ways of creating content and looking to see if you could broadly improve the pedagogy of what is being taught, and therefore the retention of those concepts, and steadily get a generation of students familiar with the hardware as well. Just to throw in a few slides about pedagogy, I do believe you'll learn more about this later in the day. Most of what students address is at the bottom of this pyramid, where most of their understanding and applications are tested in the lab at best. What you ideally want to do is to have students aim for learning objectives which address the highest levels of learning, which is where they get to create something or evaluate something or analyze an unknown situation, and then try to better appreciate a set of theoretical concepts. So at IIT Bombay, for example, one of the things we are trying to do is to get to the point where we offer student teams access to a storeroom of hardware components and let them build their own lab experiment from scratch, generate data, analyze the data, and then dismantle the rigs and put them away. And that's the ideal way of doing it. Obviously, it's a very expensive way of doing it, and it cannot be done for each and every concept that needs to be taught. But in the longer term, that's where lab instruction ought to go. So the problems, of course, with most engineering colleges that we have issues with the funding. We have issues with the ability to give quality instruction. Equipment typically is not available. If it's available, it's usually doubling up as research equipment. Tends to be expensive. We tend not to use or run those experiments which have a dependency on consumables, reagents, and so on. And we tend to stay away from those kinds of experiments where there are safety issues for the most part. And so therefore physical labs by design end up being imitations of what ought to be actually taught. So when the virtual lab challenge was given by MHRD approximately 10 years ago now, the basic idea was that you could replace physical lab. Well, for that matter, you could also attempt a physical lab or a simulator, but all of this would be accessed through the internet. The physical lab concept came about because, for example, MHRD realized that at the IITs, for example, the undergraduate labs are being used for 3 hours in a day in the afternoon, between 2 to 5 p.m. And most of our equipment is idle beyond that. And so the question that we were asked is, given the investment in putting up these labs, is there a way for us to make these labs, put these labs online 24/7 and have other students access it, including taking experiments remotely? And of course, as you can imagine, our own students love the idea of taking a lab experiment in the middle of the night, logging in and then running apparatus and generating data. But the broad idea that we steadily started working on was how to test out various lab delivery concepts, either as remote triggered labs or as simulators. And one of the things you very quickly learn is that a remote triggered lab is an expensive proposition for two reasons. One, at the end of the day, only one student is accessing hardware at a time remotely. and therefore you cannot train too many students, even if you make the things available 24/7. And there's also the risk that some of these things can be damaged as apparatus if you let the student try out too many things online, which means your design of the physical infrastructure has to be very robust to prevent abuse through the internet. The programs that we attempted, they basically can be broken down into 3 categories. We looked at how to come up with modeling and simulation labs, where these are simple interactive animations through which students learn. Then we had measurement-based labs, where we actually did the sets of physical experiments, collected data sets, and then we started feeding these data sets as if they were simulated data sets through the net. So the advantage here is the student gets to see some realistic data, and therefore gets to understand some of the inadequacies of the theory, because the theory always assumes perfect data. And the third category of things that we tried was looking at what would happen if we remote triggered hardware and let people learn to this point. To give you a sense of what the simulation and animation experiments look like, there's a range of experiments we have created by a range of partners, and you can see that they all have different looks and feel. The top left, you're trying to see a bioreactor being run, and you get a sense that the interfaces are reasonably realistic in how essentially you have to flip different switches and execute different things in the reactor. At the bottom left, you're seeing much simpler protocol in a microbiology lab of how to carry out a sequence of steps for transferring organisms from one place or one flask or tube to another. And on the right, you're seeing, again, a bit more sophisticated way of getting things done in terms of looking at a fluid mechanics kind of concept. So you can see that there's a whole emphasis on artwork and interactivity, and also in terms of providing a good quality overall experience to students. I'm going to very quickly step through a sequence of slides, giving you a sense of how we went about this for a simple chemical engineering lab. This is a fluid mechanics experiment. And if you look at that panel on the left, it is listing a whole bunch of things that you normally would anyway see in a lab manual. There's the objective of the experiment, there's a theory, there's a procedure, there are some questions that you normally ask in a while. Initially, as of initial iteration of virtual labs, just took the physical lab manual and we tried to convert the physical lab experiment into a simulator. Now, one of the things that happens when you do that is you'll realize that there are serious limitations to the existing lab manuals. For example, when you're online, you really want to get a sense of to what extent people have read the content and are able to do anything. So the pre-test, post-test becomes critical for you to design to gauge how well somebody has understood the simulated interaction. The other thing that we quickly realized is while a physical experiment may last, for example, 3 hours, and that's a typical lab session at IIT Bombay, the interactive simulator, of course, can be done in minutes or seconds, which means you are forced into designing a lot of activity as a workflow online if you are going to keep students engaged for a window of time. That forces you to hit them with higher levels of questions, the higher learning that I talked about earlier. And the whole challenge is one of how do you keep people busy for 5 to 15 minutes, which is now the equivalent of a lab session online compared to the 3 hours. So the 3 hours, if you think about it, in a fluid mechanics experiment or a heat transfer experiment in engineering, is because students are waiting for some steady state to arrive, some measurement to stabilize, and so on. And there's a lot of wasted time in between as they're sitting around waiting for something to happen. And you don't have that in an interactive simulated environment. So because the theory is already coded in the background, there are computations which happen immediately, and very quickly you arrive at some conclusions. So examples of the pre-test, forcing people to answer these things before they can move on to the simulator, giving them exposure to the theory itself, not assuming that they've read it somewhere else. Notice that this is very bare bones in terms of an interface. We're asking people to try different settings to generate different flow rates, and then from there So they start things, they watch these things. So this is an example of a lab experiment which is not a real world, realistic kind of thing. On the other hand, it is a very simple interface, and what the advantage of that is, this is accessible to students on even a phone, and it is not a heavy, bandwidth heavy kind of experience for a student. The phone thing becomes important because you've got to appreciate, especially in the time of the pandemic now, that a large number of students are trying to access content through a phone, and they're not at desktops, they're not necessarily at laptops. So some of the stats that the Virtual Labs program is saying is that approximately 60% of access of Virtual Labs is via a phone, which means you've got to design user interfaces which are phone friendly, so that people can click buttons, do things, and collect data and so on, and then do further activities with this. So in this case, there are pressure drops being measured and computed, and flow measurements being computed, and so on. So that's a simple interactive experience as a standalone experiment. But then when you look at what teachers want a complete learning management system, which is something like a Moodle or a Coursera or an edX kind of interface. They need to find a way to integrate this into the curriculum, and ideally want it as a free tool. Over the years, what you realize is different instructors are using the interactive content in different ways. Some are directly replacing the physical labs, the afternoon labs, with a collection of virtual labs. Some have started incorporating virtual lab experiments into their Moodle theory courses itself. So as I said earlier, the best scenario is you teach somebody a little bit of theory and immediately ask them to play around with a virtual lab. So in which case the virtual lab should be accessible via Moodle itself, right next to where the student sees the theory video. So the MOOC, the concept of a MOOC itself is now changing into being a highly interactive experience where you see and learn theory, and then you immediately play around with an interactive simulator, and then you go back and learn even more theory, and you keep going this way. For all the people who are involved in using this content and creating new content, it is clear to us that their understanding of the topic improved dramatically. And the basic thing here is, if you're trying to keep people busy for 15 minutes and you're designing some activities which will keep them busy for 15 minutes, you're forced, and you're doing these things online, into teaching them some basic theory and then adding some advanced work elements, so that they're kept fully occupied, given that all of these computations are nearly instantaneous when they're done through a computer online. From a student's perspective, obviously, at IIT Bombay and later on the other colleges, students are extremely happy to just play around with computers and do lab experiments from a computer interface. Physical distances are no longer the issue, and the quality of learning has obviously improved. Most importantly, they managed to do this at their own speed and at their own time. And increasingly, several of them have gotten into a mode where they're evaluating their own learning skills. So the MHRD program for the last 10 years has involved 11 partners, which led from a funding perspective by IIT Delhi. But essentially what happened is each of these 11 entities you see here broke off and created a zone around itself. That's simply because of logistical reasons, given that the mandate was that we create content, but also spread this content and understand the usage of this content. So IIT Bombay, of course, as you can imagine, is in charge of the Western region. Despite the fact that there are multiple partners in the program, the decision was made that everyone goes through a common front end, so students should not be confused with content coming out of different places. So there's a single login. All the content for the moment is free, and different developers therefore contribute into this common pool of content. Early on, so towards 2009-10, 10 labs were created or were mandated. We created more. We then got into a phase where we created many more simulators. Then the focus shifted from creating content to now asking how do colleges actually get down to using it. So the focus became outreach from 2014 onwards. But in parallel, more content needed to be created because obviously there were gaps in what was being created relative to the university syllabus. 110 experiments have been developed by the community in a very short window of time. 110 is relative to the 1,400 experiments created over 10 years. So this is the way to go. So the community coming forward to create content, learning what it takes to create content, and then solving its own problem is the way to go. And it's something that I would urge you to participate in and explore, not just today, but down the road, in trying to figure out what you need. And we will be there to help you along the way. So just putting up some list of the names of the experiments which we have created. That you can see they are typically in the computer science and electronics area, but we have things in the physics and biology domains as well. We're doing workshops and boot camps, and that's simply because it's easier for us to, rather than hold several events online one after another, it's easier to pull a bunch of people together at one place and get them to focus and concentrate, especially when it comes to creating content. So there's now a process where there's a high energy kind of event where a number of faculty and students are brought together to try and brainstorm and then create content. So we've done this at several places, including one recent at UP. The most recent one, in fact, is a boot camp that we've run through the lockdown. So which I listed at the top. So so it's over here. We've run an event through the lockdown and attempted to create a large amount of content, given that anyway, the faculty and students during the early part of the lockdown had time on their hands to sit and look at encoding some of this theory as interactive simulators. There's a team of instructors which have steadily evolved, and I need to acknowledge them because these are people who have given a large fraction of their time towards helping others create content. And so they're turning into a group of mentors in content creation process. Lots of students have also devoted a lot of time, and that's something else that we've come to realize. We really need to be harnessing the energy that the students have in creating this content. And it's about mentorship, telling them what to do, and usually they go and do a great job of it. There are two tracks now of how we do this. One is before the boot camps happen, we spend time with the faculty in webinar mode, bringing them up to speed on the basics of pedagogy and how to essentially, like like you would in creating a movie, you need to create storyboards. So you literally have to force people to visualize what activities inside a virtual lab, and you create storyboards, and then you get them to essentially put down their thoughts, and from there convert it into small tasks which involve coding. And separately, we work with the students to bring them up to speed on all the technologies which might be relevant for creating interactive simulators. For example, if you're creating a highly interactive animated content, then you need to be familiar with HTML5. We ideally want things access to browsers as content, and so JavaScript and TypeScript become important. Then you start putting all of these together, the faculty and the students. And the way it works, you don't necessarily put together students from one department in here. What you want is diversity of skill sets in a team. So the faculty could be from, let's say, chemical engineering, but the students could be from computer science and so on. Maybe you have one or two students from chemical engineering as well. But between them, they have enough skill sets to put down the theory of what has to be created. And they also have the coding skills, whether it be the browser user interface or whether it is the back-end simulator itself for evaluating the theory online. And we then get into figuring out how to evaluate students online, because one of the challenges, as you can imagine, is how do you grade people who are doing virtual labs. There are challenges also with how to make sure your content can be amount of trouble, because there are different ways people want it hosted. Some people want it running off a central server on a cloud. Some people want it running on a college server, and some people are happy with downloading the code and running it on local software. So in the bootcamp, we had a large an effort to reach out to a large number of participants across a large number of cities, and in some ways, this is the way to go. The usage stats for virtual labs, as you can imagine, and MHRD has been very curious about this. It's gone through the roof during the pandemic. With numbers of people, including international, because nowhere in the world has there been this quantum of content creation. In fact, we even had the Chinese come in and try to access the virtual labs content created. to the MHRD program. We have a lot of content which is housed on a platform called Git, and the idea is this is an open source code maintenance platform. And the idea is as people create virtual lab content, the next team which comes along to create content should not have to learn everything from scratch. Maybe you can borrow bits and pieces of code and bring them into your own experiment design. That improves the thing for the whole community. That speeds up development for the whole community. So we've been working on creating platforms for code maintenance and development. So there's a certain process for how content that's been created goes national. So there's, at this point, hopefully you're clear that there are two programs afoot. There is Virtual Labs, which is the content already created by the IITs and already available for use. And then there's a new content being developed. We're calling that VLab Dev. So when new content gets created, it doesn't automatically become accessible to the entire community. We actually take it through a review process very systematically through peer reviewers and then domain reviewers in particular. And once we're convinced that the theory is all correct and that the basic bugs have been pulled out, we are in a position now go host the content online. And one of the major advantages for a college to do this is you get international visibility because you get branding of the content that you create. The only insistence we have is that this all be free and open source to the student to use. The team structure that I talked about, the faculty, students of different disciplines, and so on. And the process has been refined so that we are able to condense it down, given that people have a lot of demands on their time. So there's a lot of effort where we train people in advance on various things through webinar mode, and then when a physical event happens, it's done typically over a period of 4 to 5 days. Where we get down to the creation of content as opposed to teaching them the basics of content creation. And we even try to get a review of the content developed happening in real time so that there's real-time feedback to the teams. And we have started certifying teams which are creating these things. So we're looking at different models of fast-tracking these things, getting colleges to fund their own content creation bootcamps, looking at the universities to get engaged in mandating the usage of this. As was implied earlier, AICT is going to mandate that 20% of lab experiments be now done virtually. And this will continue post the lockdown itself. So looking at how to bring out better labs, and the moment you create a lab, there are ideas of improving the pedagogy, improving the user experience. It's like creating a video game. You create one thing, then students in particular are looking for the next most challenging thing to do. So how do you improve the level of content and get more and more people engaged? There's more emphasis on the bootcamp sessions itself and on certification of developers and on the review. You'll find a lot of this detail at these links, which I'll just quickly flash through, but you'll be able to access this from the slides that I'll leave behind for use later. Where is the Virtual Labs program going? We're looking at an open platform for a large number of developers to contribute and looking at doing more of these events nationally. Technology-wise, we are trying to do this entirely through browser and cloud-based simulation, and the phone becomes an important user interface. And we are trying to build technologies which will allow for this to integrate into a MOOC platform. So Moodle is not designed for use of virtual labs. So at IIT Bombay, we have been investing through the data center that I run on a platform called Bodhi, which is a Moodle replacement. And we hope to find or build the functionality to integrate virtual labs into the Bodhi framework so that students can go back and forth between theory and interactive simulators. There's going to be improved functionality in terms of authentication of students and validating it's the right student taking the experiment. That's because evaluation becomes critical down the road. How do you get people to start an experiment, pause it, go do something else, come back and resume the experiment? How do you have persistence in this? And we're trying to build in functionalization. And how do you make sure that no two students back to back get the same virtual lab user experience? Because then, for example, when you're grading them, they're just going to cheat. So how do you therefore randomize the various computations that they are going to have to do? And how do you give them different settings, random settings, and force them into doing slightly different experiments so that each student has their own unique experience? We're looking at incorporating the best pedagogical practices and frameworks for creation of storyboards, and you'll hear more about this. There was brief mention about augmented reality by the VC earlier. We're looking at that, but that's at the high end of the spectrum because that's very intensive in terms of what it takes a student to experience. But the other thing that can be done is as more and more students in virtual labs, we start learning a lot from the analytics. So for example, the way a strong student takes a virtual lab is different from the way a weak student takes a virtual lab. A weak student goes back and forth, for example, looking at the theory, coming back and trying something on the simulator, and they waste a lot of time. And if you just simply start paying attention to the time they're taking on an activity, you start learning whether somebody is going down the right track or not. And what that means is you can actually personalize the lab experience to a student. And we're playing around with these as features. You can actually give hints to students as they start taking an experiment, and you see them start to struggle. And you don't need a teaching assistant online to tell them to do this in real time. We hope to create more regional centers and recruit more nodal centers, so that helps with the further rollout effort and run more events. And we also expect to start creating content for polytechnic colleges and also science colleges. A last thought on this. At IIT Bombay, we started with rollout. We focused on the creation of new simulator labs. We are shifting focus back to the creation of hardware labs as well, because at the end of the day, you cannot be teaching a generation of students on how to understand stuff through just simulators. They have to see the real thing at some point. So how do you get them to now look at real apparatus, and how do you design experiences around the real apparatus? And therefore, how do you create low-cost hardware experiments there around it? That's the next generation of things that we hope to engage with. And many of the kids who get into building their own hardware immediately get excited to work with us on innovation challenges. So we have realized that the reason to get into virtual labs is not simply teaching, but that in the longer term, there's so many great things we can do, the talent that we have around us. To give you the connect details at IIT Bombay, do get in touch with us if you wish to learn more about the virtual labs and the VLabs effort, and the organizers of this event will obviously also be accessible to you if you wish to learn more.
Thank you, sir. Am I audible? Yes. Okay.
Yes, sir.
Thank you, sir, for briefing us, giving a full introduction about the virtual lab, how to use, and what are the future goals, how to run a boot camp and all. Extremely thankful you for taking us all the inside outs of the virtual labs. Now, I request Dr. Abhilasha Mishra ma'am, the regional coordinator, Mathwada region, Maharashtra Institute of Technology, Aurangabad, to take us or give us how they started from their journey from Nodal to their regional center. Before that, let me take this opportunity to introduce her, Dr. Abhilasha Mishra ma'am. She is working presently as an associate professor in Department of Electronics and Telecommunication Engineering of Maharashtra Institute of Technology, Aurangabad. After completing BE from MIIT, she pursued her higher education ME from the Government College of Engineering, Aurangabad. She has completed her PhD in antenna designing from Kawai 3 Bhindai University, North University, Maharashtra University, Jalgaon. She is a regional coordinator of Virtual Laboratory, IIT Bombay, Regional Center of Mathwada region at MIT Aurangabad. And she has published 55 research papers, book chapters on antenna technology, image processing and remote sensing, and optical fiber communication. She has also published 2 patents in Indian Patent Public. She is a recipient of Best Paper Award in 3 IEEE conferences, ICMO 2017, IEEE IAW 2013, IEEE INCE-MIC 2018. She has received a prestigious award of IETE Professor S.N. Mitra Memorial Award 2013 for her outstanding contribution and leadership role in radio, broadcast, science and technology during last 10 years. She has developed first virtual lab of Mathwada region hosted by IIT Bombay portal. She has organized IEEE conferences of world repute, that is IEEE Indian Antenna Week 2013, IEEE Applied Electromagnetic Conference 2017, for which the research persons were from MIT, NASA, USA, and IITs and NITs. Over to you, ma'am.
Thank
Ma'am,
you,
are
sir,
you there?
for such a brief introduction. Am I audible?
Yes, ma'am. Yes, you are audible.
Okay. Is it visible to you, sir?
Yes, ma'am. It is visible. Yes.
Okay. Very good morning to everyone. Initially, I would like to congratulate a visionary principal of Jabalpur Engineering College, Dr. A.K. Sharma, sir, to establish a nodal center at Jabalpur. And I would like to appreciate the efforts taken by Dr. Ruchi Nigam ma'am and Dr. Prashant Jain, sir, the nodal coordinators for this nodal center, for taking the initiative to start the outreach program immediately after getting the nodal center. So a warm welcome to all of you. I would like to deliver my talk on MIT's journey from nodal to regional center. So already we have got the brief introduction from Dr. Santosh Narona, sir, who has explained us from pedagogy to the implementation of virtual lab. How does it look and how it is contributing in understanding the theoretical as well as practical concept. So we will see what exactly the education system we are facing right now and the role of online teaching, virtual labs on digital applications of logic gates, objectives of virtual labs. Already it has been briefed in descriptive way by Naruna sir. And we will see the journey from nodal to regional center. List of VLabs hosted by IIT Bombay and which has been developed by MITians, my institute contribution. Learning outcomes for the students if we go for the virtual labs, and what are the milestones of our regional center. So as we know that we are into academics, being a part of as a teacher or as a learner. So we are observing this education system since from our childhood. So we know that ancient education system was the Gurukul, where we used to learn. We have heard about this, that under the tree, the Guru is used to sit there and he used to teach all the students. Then after the research and development of the technology, this Gurukul system has been modified and changed a lot. And then formal education system has been reached to this level, which we are currently going on. But this pandemic has changed the complete learning management system. And now the latest education system is e-learning education system. We know that various platforms are available for demonstrating the theoretical concept. Earlier, we used to demonstrate this on the board in classroom teaching. But now as the online teaching has become mandatory for all of us in this pandemic effect, so this online teaching, we are using various platforms, and that is Microsoft Teams, we can use Google Meet, WebEx Meet, or some of the faculties, they are uploading their video or direct, they are going for the live streaming as well on this YouTube channel. The medium which we are using is based on the PowerPoint presentation or whiteboard or graphic board we are using to explain the theoretical concept. But for the practical, we don't have any kind of effective medium. And now we are looking towards this virtual labs. Virtual experimentation explains the theoretical concept as well as the practical concept, and it is the very effective medium to learn the basic things till the advanced level. So this virtual lab has been established And MSRD has taken initiative, especially IIT Delhi has started this in 2011. And after that, it has been decided that IIT Delhi alone cannot handle all the nodal centers. So it has been decided to hand over the responsibility to the nearby IITs or NITs. And this is how my institute, which was associated with virtual lab initially with IIT Delhi since 2011, then we came under IIT Bombay in 2015. So now IIT Bombay is the mentor institute for all of us, and we are working as a nodal center. So initially only nodal center was the concept to circulate the information about the virtual labs so that the students can use it in maximum way. After that, it has been decided to have one regional center which will handle all the nodal centers of the region. And this is how the MIT's journey has transformed the nodal center into the regional center. Now coming to the virtual labs, we know that we are, though we are from various disciplines right now, but we understand that in 11th, 12th also we have studied the logic gates. So if I show you this logic gate, which is of AND gate, so which is having the 2 inputs and 1 single output. And output is nothing but the multiplication of 2 inputs. The binary combinations for the 2-bit inputs are 0001 1011. For AND gate, if both the inputs are 1, then only output will be 1. Now this is what we teach in our theory class, but we don't have any kind of practical application which we can deliver in the class while teaching the theoretical concept. So as I told you, for explaining theory as well as practical, virtual lab is the effective medium. So if I explain my students that I can control the wiper by using the AND gate, in which these 2 inputs are handled by the one ignition and one the wiper. So if ignition is on and wiper makes on, so then only two inputs are on. So this AND gate will give the high output, and that will control the mechanism of this wiper. So if I explain that if single input is 1, it won't work. If this input is 1, both are off, then also it won't work. If this single ignition is on, then also it won't work. But if both the inputs are on, then this wiper will be on. So this is how digitally I can control the mechanical action that can be very well explained to the students. Leading to this, if I work on this OR gate, I know that addition of 2 inputs or number of inputs will be the output of this OR gate. So as the name suggests, any one of the input is 1, then output will be 1. So if B is on, if A is on, or if both inputs are on, we will be getting output as the high logic. So similarly, same thing if I explain in the class with some practical applications, so it will be received by the students in a better way. So in a process control system in which I have to control the 2 physical quantities like pressure and temperature. So in this, if temperature becomes or crosses the high level, so this process should be stopped. So here see, if it is getting high level, then it is showing the red. Similarly, if pressure is crossing the limit, so again, this system becomes off, and this can be controlled digitally by this OR gate. So this is how it works on. Similarly, NOT gate, we also call it as inverter, which inverts the input. If input is 1, output is 0. If input is 0, output is 1, vice versa. So now here in this control tank, in the process control, that this tank should not cross the limit of this 1/4 level. And if the solution goes down to this 1/4 level, the LED should glow to high as a high alarm, right? So see how it works on. So if it exceeds the solution, it doesn't make LED glow because this is inverter, this high logic is there. But as soon as this solution crosses the limit of 1/4 level, this is 0, this will become 1, and then the LED gives the red sign, that is the danger, you need to look after this. So again, this simple inverter is able to control the mechanism, and this gives a very good impact of learning. Now, in a nutshell, what we can talk about the virtual lab. So virtual lab is nothing but the integrated learning, which includes animation and sometimes video tutorial as well. So which gives us the better insight, and it gives freedom to make mistakes. So already Naruna sir has shown that how the virtual lab looks like when you open the VLab.com. So on that, you will see the experiment. Student can learn through the theory which is explained or which is available on the screen of this VLab website, and you can study well about it, and then you can perform the practical. So before performing the practical, pre-test is there. This pre-test will ask the student to understand how much this student understand the preconcepts which is required to proceed for the learning of the experiment. So this is how the pre-test is there. Then student will go through the theoretical concept, student will perform the simulation, and then he can answer the post-lab quiz. So whatever the learning he has received from the simulation, he can answer the quiz after the post-lab. So self-evaluation is the main constraint for the student, and nobody is there to look after. So there is no hesitation for the student. Sometimes if he makes all wrong answers, still he can learn it by his own. So it's a freedom to make mistakes, and which will lead to the self-evaluation for the student. And as it is available 24/7, it is on-demand lab. So altogether, it is an integrated learning management system which helps the students to learn by their own. Now, here is the journey of Maharashtra Institute of Technology from Nodal Center to Regional Center. Within the span of 2 years, we have reached from Nodal Center to the Regional Center. So this is the first lab developed by the Nodal Center of Marathwada Institute of Technology. And this is, you can see this, if I contribute, means if my institute contributes any lab. So this kind of visibility we are getting on this IIT Bombay's portal, that this lab is contributed by Maharashtra Institute of Technology, Aurangabad. So this is nationwide visibility for the contribution of the faculty and student group. So this is the recognition we got in local newspaper after developing the simulation lab for the computer networks. And I along with my colleague, we have developed one format, and the system of this virtual lab is so transparent. Whatever you are contributing, that is getting reflected by your name, whether it is the lab developed by you, so it is given the recognition as for your institute. And similarly, if you are developing anything like here, I have developed only one single format, so it is also getting reflected as this particular format is developed by so and so faculties, so it should not get the edited. So this is the footer note you will always get. So this Nodal Center coordinator will understand this. And now this is the list of virtual lab Nodal Center which our regional center has. So mainly pointing this, we have 2 universities. They are the nodal centers under our regional center. So SRTM University of Nanded, that is Swami Ramanand Tirth Marathwada University, and SGGS Nanded, well-known institute of the same region. Similarly, Dr. Babasaheb Ambedkar Technology University Lonere is also the nodal center under our regional center. And now happy to say that Jabalpur Engineering College is also one of the contributor as the national nodal center for the region. So there are various regional centers, 6 to 8 are there. I'm listing here only 5. So we are the 3rd regional center, and which is looked after by me and my colleague, Dr. Prashant Gupta. He's working as regional technical coordinator. And this is the 3rd regional center declared by the IIT Bombay. So we have organized boot camp in association with the IIT Bombay, and there 21 teams have been contributed. So 114 participants were there. So this was organized in February 2019, and physically everyone has to be present because there was no pandemic effect there. So now the boot camps are going on online. So you can think of to host this kind of event as well. During this event, we have developed 21 virtual lab experiments, and which has been hosted on IIT Bombay's portal. The participants got silver certificate, and under the some improvements suggested by IIT Bombay, this silver certificate has been modified and again given to the participants as a gold certificate. So this is the contribution of my institute and my colleagues who have contributed for the development of the virtual lab. So we have not restricted our nodal center only for popularizing or using the virtual lab. With that, we have contributed in the content development. And this is the computer network lab developed by Ms. Madhu Jaiswal. She is the faculty of CSE from MIT Polytechnic, and along with me, we have developed these 6 labs. And Dr. Bhagwan Toksha, he has contributed engineering physics lab from BSH. One more lab has been contributed by me, signals and systems, as I belong to ENTC. Polymer processing lab has been contributed by Dr. Prashant Gupta. Machine tools lab has been contributed by Mr. Trishul Kulkarni. Theory of machines lab has been contributed by Santosh Kulkarni sir. Software engineering lab by Ms. Sushma Deshmukh ma'am. Power electronics by Professor Rajaguru, and Polychem lab by Pallavi Shindikar ma'am. So this is how we have contributed in e-content development. And as I told you, Batu is one of the institute who means university who has the nodal center. So we had the recognition in newspaper, local newspaper also. So this is how we are looking to have the spreading of this virtual lab. So this is the social contribution from the nodal center. And we also got recognition for the newsletter Abhasi, which is published by IIT Delhi. And as I told you, IIT Delhi is the initiator of this virtual lab. So Professor Ranjan Bose is chairing. He is the nodal national coordinator of virtual lab project. And I think it is biannual. Yes, it's biannual publication. So the developments and achievements of all the nodal centers is published in this Abhasi newsletter. And we got good recognition for our institute's contribution. We have organized the boot camp here, and these are the points which help us to have the shining nodal center as recognition in this newsletter. So we are the 3rd regional nodal center, as I told you. First boot camp of the region we had organized, 4 VLabs approved and hosted on IIT Bombay's portal till that time. And we had 7 nodal centers, and yes, we are having 7 peer reviewers and content developers. So the faculty members of MIT is taking a lot of interest in contributing the e-content as well. So we got an opportunity based on our performance that our students got the internship, Naman Chakravarti and Gaurav Kar with IIT Bombay's Virtual Lab Center. So this is, you can say, the brief journey. In 2016, we have developed the lab. Then we have formed 2 other. Is there any question, Vandana? Hello? Okay. Hello, am I audible?
Yes, ma'am, you are audible.
No, some of the participants have raised hands. So is there any question to them?
Ma'am, in the chat they did not.
Okay.
So you want to take now, or I will ask them to post it?
Okay. Okay.
Yeah.
So we have formed many nodal centers, as I told you. So summer internships and short-term internships are also available for our institute students and at IIT Bombay. We have organized boot camp, and we are contributors in content development. So this is the learning outcome for the student, that they can work on new technology with the experts from IIT Bombay. They can get associated with the students of all India level regions like IITs, NITs, some of the universities, Shivaji University, SPPU University, Batu University, this is Pune University, Solapur University, some of the autonomous institutes, deemed universities, SRTM University, and reputed private institutes as well. So they can contribute as a key member, students can contribute as a key member in Digitizers Forum. So institute can form a students forum who can contribute in the content development. So training programs will be organized by IIT Bombay for the students and faculties. Like bootcamp is the systematic program which help the students and faculties to learn how to go from scratch to the content development. So internship opportunities are available, improvement of leadership skills we can see in our students when they perform together with the different regions, because it is not necessary that if suppose Jabalpur Engineering College students take part in development, so it is not necessary that the same faculty of your college will get the same students of the same institute. So the cross connection will be there, so that there will be a good harmony and leadership qualities which will be enhanced in the student. So mentoring of junior students is one of the key aspect. So the students, those who are passing out or those who are coming out of it in final year, they can teach the students or newcomers, so they can become the mentors for the newcomers. So and they can work in interdisciplinary peer group learning, because it is not necessary that electronics student who is participating in the content development will develop the lab of electronics only. He can contribute in content development for mechanical also. So this is what it is, interdisciplinary peer group learning, and they will contribute in content development, and for their contributions the IIT Bombay will certify all the students whether they are contributing in content development or they are going for the internship. So they will be certified by the IIT Bombay. So these are the milestones. So Digitizers Forum audit course can be launched by your institute. Training programs has to be organized for the in-house training and the outreach, just like you are organizing right now this outreach program. You can also contribute in participation of your students and faculties in bootcamps or bootathons. You can mentor the region students, and it is an interdisciplinary peer learning. So you can also plan the workshop for organizing this kind of event at your institute. It may be after pandemic also, or during the pandemic, you can also think of the online host the online events. So in this way, we have contributed 125 experiments developed by the team members of MIT. Now just have a look on this structure, that virtual lab, as I told you, it was initiated by IIT Delhi. So it was the MHRD's consortium of 12 participating institutes, which has number of IITs and NITs. And as myself, means our institute belongs to the Maharashtra, we got associated with IIT Bombay. Then once again, the decision has been taken that we should not restrict to the region. So IIT Bombay is now forming the nodal center in MP region also, that is Jabalpur. So this is how the IIT Bombay is trying to spread the usage of virtual lab by the students and the faculties. So after under this IIT Bombay, our regional center ID03 is working on, and under our regional center we have formed the 20+ nodal centers in this region, and which has been handled by nodal coordinator and nodal technical coordinator. And as already Ruchi ma'am has initiated in your institute, so you will be having the departmental coordinator and departmental technical coordinator. So they will act as the facilitator of VLab activities in their department, and this will be briefed to all the subject teachers who is looking after the practical subjects by these facilitators of the department. And faculty can select the number of experiment as per the syllabus, as told by the Narona sir, that we are trying to overcome the research gap depending upon the syllabus. So IIT Bombay has asked to submit the syllabus of various private and state universities and central universities, and they are trying to make the curriculum or the planning such a way that the virtual lab will give exact mapping of the syllabus for different types of syllabus which we are getting from the different places. And now this subject faculty or subject coordinator will look after the student forum for and they will contribute in the performance of the virtual lab, as well as after the performance of the virtual lab, they will have to submit the online feedback. Just now we are conducting this outreach program. You will try to learn systematically the theory, the concept, and the pedagogy by Prashant sir, my next talk of my colleague. So you will understand, and then some of the faculties of Jabalpur Engineering College will brief you about how to use the virtual lab of different domains. So once you learn it, you will have to submit the online feedback, and this online feedback will be counted on Jabalpur Engineering College Nodal Center. So this is how the whole procedure goes on, and we need to follow all the instruction given by the nodal coordinator. And these are the links you can access to for the virtual lab. So VLabs IIT Bombay means vlabs.iitb.ac.in. You can find new developed labs on this VLabs Dev website. And the main, as I told you, it is the initiative of the IIT Delhi. So this is the national website. You can say that it is vlab.co.in. And these three are the websites of the IIT Bombay. So this will help you. And it is not necessary that as we belong to IIT Bombay, we need to perform the virtual labs, which is available on IIT Bombay's portal. No, we can use any of the virtual labs, whether it is developed by IIT Kharagpur, IIT Kanpur, IIT Delhi, or COEP. So whatsoever it may be, you can perform the virtual labs. Only you have to submit, and you have to be very careful for submission of the feedback, so that the usage of your nodal center will be high, which will give us the good recognition in the nodal centers domain. So this is the team of MIT, which is contributing continuously in popularizing the virtual lab concept. And we are also helping the faculties for the e-content development. And if you need any kind of support, so IIT Bombay along with this team is always available to you. So Dr. Bhagwan Topsha is from Basic Science Department, Dr. Prashant Gupta from Plastic and Polymer Engineering. Though he's from plastic and polymer, but he has contributed in some mechanical and chemical labs also. So it is not, as I told you, it is the interdisciplinary subject. If you have command on the subject, you can contribute for such kind of applications. Trishul Kulkarni from mechanical engineering, he is working as the nodal coordinator of our MIT's nodal center, and he is the nodal technical coordinator B Rajaguru from electrical engineering department. And this is me. So anytime, at any point of time, we are available to you and we can support you. So let us all try to contribute in nation building through the virtual labs community. Thank you. Thank you, one and all.
Thank you, ma'am. Thank you for a very well motivating journey from regional center to nodal center to regional center. Hope we will also be soon. I think there is one question. Is it okay, ma'am? Would you like to take any questions?
Yeah, sir.
Yeah. Miss Karthik Gupta, you can unmute. I am unmuting you. You can ask your question related to this talk.
Hello,
Yeah, please.
Ma'am, I want to ask, how can I contribute in virtual lab?
See, first, as
Hello.
you have got recently nodal center, first you try to understand the concept, like you are attending this one-day program. So you will get a good thought about the virtual lab and clarity about the virtual lab content and how it is developed and how you can use it. So after getting it, you can use some of the labs, you can submit online feedback. And once you got some concept about it, you can proceed for the content development. So within span of 2-3 months, IIT Bombay is planning to launch the new boot camp, online boot camp. So you can contribute in that with the group of students you can form in your institute, and you can ask some of the faculty who can also, like I'm faculty of electronics engineering, so I wanted to go for the signals and systems lab. So I collected 2 students from electronics background and 1 student from CSE. But now the concept has been changed, 1 electronics student and 2 CSE. So CSE student will do coding for this, and electronics will understand how the manual has been developed, lab contents will be developed. So student group can be able to perform together to develop the content. So systematically you can learn it through the boot camp, and possibly we will be launching it very soon. So gets updated from our side and Ruchi ma'am. So once you get the information about the content, you can participate in.
Okay, ma'am. Thank you, ma'am.
Any other questions from the participants? Okay. If not, let's continue with the session. Thank you, ma'am, once again for briefing us.
Thank you,
Your
one and all.
journey. So now, I would like to request Dr. Prashant Gupta, sir, the Regional Technical Coordinator, Marathwada Region, Maharashtra Institute of Technology, Aurangabad. Before I hand over the session to him, I would like to take this opportunity to introduce him. Dr. Prashant Gupta is working as an assistant professor in Department of Plastic and Polymer Engineering. He has completed his PhD in Polymer Science and Technology and postgraduate diploma in Chemical Technology Management with a gold medal from Institute of Chemical Technology, Mumbai. He was a recipient of prestigious UGC SAP fellowship scheme during ME and PhD course. Regarding virtual labs, he is a regional technical coordinator of virtual laboratory, IIT Bombay Region Center at MIT Aurangabad. MIT Aurangabad, along with an online content developer, mentor, and national reviewer regarding content creation for the same platform. He has industrial research and development experience of 4+ years in various managerial positions. He has published 50 research papers, book chapters on online teaching, learning, novel materials, and new methodologies, and has presented his work at 12 international and 5 national conferences, of which one of the invited talks was in prestigious Eurotech conference organized by Society of Plastic Engineers USA in Lyon, France in 2013. He is recipient of various national and international awards in management, sports, and organizing events, conference projects, and competition events. Over to you, sir.
Many thanks, sir, for giving a brief introduction. So I hope I am audible and the screen is visible to all of you.
Yes, sir. Yes.
Yeah, great. Thank you. So I would like to take this opportunity to thank the organizing committee of this outreach program, especially Ruchi madam, for taking all the pain to organize this event. And as such, Dr. Saab has given already a brief intro about me. But then my name is Dr. Prashant Gupta, and I'm working as an assistant professor in the Department of Plastic and Polymer Engineering at Maharashtra Institute of Technology. In the capacity of virtual labs, I'm working as a regional technical coordinator for whole of the Marathwada region. And along with the same, I'm also a content creator, mentor and reviewer for various laboratories in chemical engineering, chemistry, plastic and polymer engineering, and civil engineering. So my topic for today is going to be teaching learning pedagogy for virtual laboratory. So before we actually get into the slides, there is a particular need to understand the teaching learning pedagogy, not from the faculty perspective just, but also from the student perspective as well. So from the faculty perspective, probably the need would be as to how we should plan our session, right? So we'll try to connect the teaching learning pedagogy with the virtual laboratory concept, and we'll also try to see why the teaching learning pedagogy is important for both the students and the faculties. I mean, when I'm talking the students part, even the students, should have a fair bit of idea on as to what they are going to expect from the class that they are sitting in, right? So this part is very, very important as such. So we'll just go ahead. Okay. So there are three domains of learning, right? The first one is cognitive domain. So when I'm looking for from a faculty perspective, the questions that in my mind are, whom I'm going to teach. So that is why, before I was starting, I asked Ruchi ma'am in particular, so what kind of audience do we have? So do we have students or do we have just faculties? And the answer that I got was that we have a mix of students and faculties as well, right? And that is where the talk becomes very interesting, because then we wanted to also touch upon the student side of things, right? And how virtual labs will aid faculties as well as students, right? So the questions that are generally in a faculty's mind as or a teacher's mind is that who is the audience to whom I'm teaching, right? What is the topic that I'm teaching? In today's world, with the advent of technology in online teaching learning and a lot of various methodologies, other pedagogies, that the real challenge becomes making it really interesting for the students. So the next question that comes to my mind is how am I going to teach it, right? And how will I know if the students have understood the concept that I've taught them or not? So these all are things which are really important to be understood before I start my lecture as a faculty. And from a student perspective, a student is really keen to understand the concept that he is going to learn in that particular class of maybe 45 minutes or 1 hour, right? That is where the curiosity levels start going up, and they are very, very important in the concept, in the terminology of engineering and technology, especially because there is a lot of brain processing that keeps on going inside our mind, right? And that is where this cognitive domain of learning comes into picture. So cognitive domain basically deals with the intellectual side of learning, right? So we are more talking about the brain processing here, right? And of course, we know for doing processing, we need to have a prior knowledge of things, right? So it involves knowledge and the development of the intellectual skills that we have or we may possess, right? Of course, there are two more other domains, but when we are talking specifically about teaching learning, or when we are talking about this lecture kind of arrangement, not specifically moving on to the practical sessions, we are more talking about the cognitive domain of learning, right? Going forward, maybe affective and psychomotor are really relevant and important when we are talking about actually doing things with our hands, or taking care of the practical sessions, trying to follow what the faculty is trying to teach us, and things like that. So moving on, affective domain is the domain which involves the manner in which we deal with things emotionally, right? So we all know, I mean, we all are matured enough to understand that emotions play a big big part in making our decisions of our life, right? So be it why you got into engineering, or be it whether you want to do or attend a particular session or not, or do you want to do the lecture. You certainly, as a student, feel that okay, I don't feel like doing a lecture today, right? And even faculties, they can't feel like that, but then there would be decisions based or driven on emotions. So that is why affective or the attitude part is very, very important, and the affective domain touches upon this attitude part of learning. So how do we deal with things which are in an emotional manner, such as feelings, values, appreciation, enthusiasm, motivation, and attitude. So we all must have heard from our faculties that having the positive attitude is very important to grow in your life and make a good career. So this is something really, really important in your life. And moving on, the psychomotor skill, psychomotor domain focuses on motor skills. So motor skills, I'm not talking about a vehicle here, I'm talking about moving things, moving parts of your body. So how does say for example, when I'm trying to drive a car, my cognitive power has to be really in connection with my controlling of the pedal through my foot, right? So if you find that I have to press clutch and I press brake, my vehicle would turn off, and then it may lead to worse conditions than I've just mentioned, right? So psychomotor is like actually moving your things. So for example, it's just a basic example in a chemistry practical. Let's say you want to do titration, right? And in titration, you have to fill the burette. So you have to work in a very synchronized manner. You have to put a funnel on top, and you have to fill the burette with a conical flask. You would find that if your hand does not work in a synchronized manner, you would end up spilling the solution maybe on your hand, or maybe may end up in you may end up in breaking the glassware. So that is something that we don't want to do, because then when you learn good, you would do good things in your career, in the industries as well. So this psychomotor domain focuses on the motor skills and physical skills or actions that require physical coordination. So that is why you must have heard in cricket as well that there is something like an hand-eye coordination, right? So these are things, these are different domains of learning which are very relevant to engineering and almost all the courses that one studies, right? Okay, now there are two approaches that we see in today's world, right? When we are talking about this teaching learning methodology. So before actually going to this bigger picture, well, let us look at the smaller picture. So we can see four quadrants here, right? And in these four quadrants, we can see on the top right quadrant we have high-tech student-centered, right? And on just below that we have low-tech student-centered, we have low-tech teacher-centered, and high-tech teacher-centered, right? So what we are trying to break down is our teaching theory, right? So we can divide our teaching theory into basically four quadrants that we see here, or four categories, which are basically based on two major parameters. One is the level of technology which is used, right? So we can see the level of technology can be high or low, right? And the second thing is the orientation of teaching that is there. So whether the session or the content that you are being taught is oriented in the teacher's manner, that is teacher-centered teaching, or it is in the student manner. So moreover, these forms of personalized teaching जो आज हमें देखने मिलती है that we see in today's world, that is more or less student oriented, because we are now gradually shifting towards what Western countries are following, right? So these are different different methodologies that we see. So one is a teacher-centered methodology, and other is a student-centered methodology. Whereas on the other end you have this this high-end methodology and high-tech methodology and a low-tech methodology, right? So what is a teacher-centered approach? So you can see here that the teacher-centered approach. So teachers are the formal authoritative figure here, right? So though in today's world, it's very different to what we used to see in the Gurukul Kal that we used to say, right? It's very different to what we had in the primitive age, and more so it is because of the advent of technology, right? So teachers are the main authority figure, and they are considered to be the experts, and students are generally considered as empty vessels. So a lot of times, the students are in a better position to take in things because probably they don't know anything about the concept. On some occasions, it can be different as well. So wherein you see that, okay, we have a basic knowledge about the concept, and then we can go on to that advanced stage. So students in this approach, where the approach is teacher-centered, the design of the program or the course or the content is on a teacher-centric approach, the students are viewed as an empty vessel, right? And they more often than not they receive their knowledge passively. So the mode of teaching is not active, so they will receive the knowledge passively through lectures and direct instructions with an end goal of positive results from testing and assessment. So the idea here is to have good results at the end of the course or the semester, right? Whereas when we are talking about a student centric approach, right, which is teachers still are an authoritative figure, right? So teachers are the facilitators in this kind of a model, okay? And but the difference from a direct instruction or a teacher-centered model is that over here, both the teachers and students play an equally active role in the learning process, right? So teachers' primary role is to coach and facilitate, right? Facilitate the student learning and overall comprehension of the material. And the teacher also has to measure the students' learning through both formal and informal forms of assessment, right? So the assessment forms can be, there can be group projects that is what cooperative learning means, right? So you are working together, right? There can be, class participations that can be done. So this is more focused towards the student. And, when we try and compare a teacher-centered approach versus a student-centered approach, the major difference that pops out in my mind is that, formative assessment, which is like when I teach in a lecture, I try and ask questions then and there to understand whether or not you are getting my topic, right? So that is what is formative assessment, whereas a summative assessment approach would be taken an exam which is taken maybe at the end of the month, something like a midterm exam, or maybe at the end of the semester, that is your end semester exam. So these are two different approaches, right? Now, when we are talking about this pedagogy, so pedagogy is nothing but a method and practice of academic teaching, right? So the goals that you set on based on the pedagogy has to be smart, right? So and they have to take the career graph of the student up, right? And it should be in a sense that you can see the picture of a worm, right? So you have to be the worm that bores through the body to reach the milestone or the fruit. That is apple. So you have to actually go through the book to eat the apple. So that should be the inclination of pedagogy. So on the right hand quadrant, you can see that there are again the 4 quadrants that we had saw in that image. The only difference here is like there are different pedagogies that are placed, or different types of teaching methods pertaining to different pedagogies that are placed, right? So we have had a difference between the teacher centered and the student centered approach. Now what is the difference between a high tech and a low tech approach of teaching, right? So obviously there is one standout feature that the technical or the technology usage is more so in high tech, right? So in today's scenario of COVID-19, we are almost involved in teaching which is high tech in nature, right? So we are using a lot of internet these days. We are using online classes, Zoom platform, or Google platform, Gmeet, or maybe Microsoft Teams, or there are a lot of platforms that have actually come up. Some of them free and open source, and some of them are license based, right? So one of the disadvantages of a high tech platform can be, say for example, if a teacher is teaching in a class and the students are asked to take notes. So if those notes are handwritten, you would have more coordination in your spelling, in your grammar, and writing. If the option will be of using a computer and typing down the notes, the student very early in his life, he would be exposed to spelling corrections and grammar corrections. That is the autocorrect method that comes with the computer, and you would find that it would lead the student to be weaker in spellings and writing skills. So this is one of the disadvantages that you have with high tech learning. But then more often than not, of course, the advantages will supersede the disadvantages in this case, and we try to see all these categories one by one, right? So we'd first see the lower quadrant, which is a teacher-centered low-tech quadrant, right? So we see that there are two things. So direct instruction and there is kinesthetic learning, right? So direct instruction is what we see in the class and what we normally teach in the class, maybe a blackboard room, a traditional methodology, जो हम देखते हुए आए, right? So the regular teaching is through lectures, and teacher will demonstrate. So the idea of teaching is basically teacher-centered, right? So he will look at it from the perspective of how I want to teach a particular topic, right? And this kinesthetic learning is basically more of hands-on learning, right? But it is still in the teacher-centered low-tech quadrant, because the students are basically asked to do things, make things, or create things, right? And they are asked to perform rather than listening or watching. So something like a role play. So in skits, this happens that you are given a role and you play it. Say, for example, in my class, I asked that, okay, for example, I ask a student to be a plastic pipe, and then he will talk about his own, properties, and I mean the pipe's properties, and so kind of a role play kind of method, right? So now we move on to the above quadrant, that is a flipped classroom, which is a teacher-centered high-tech. So teacher-centered, it is slightly on the lesser side, right? And it is high-tech in nature, right? So flipped classroom is basically a blended learning model, when now this has also gained importance nowadays. So what usually happens is that teacher may give you some videos, maybe some links from YouTube, or maybe he'll record his pre-record his lecture, and he will ask you to view this lecture on the internet, maybe on a YouTube channel, or maybe on his own Moodle channels that Norona sir was talking about, right? And what is expected to be done in the class? So traditionally we learn in the class, right? Whereas of course we are going to learn in the class in a flipped model, but the difference would be that you are going to work on what you have learned at your home from the video, and you are going to work on that, maybe some question answer sessions, right? And things like that. So more of practice is going to happen in the session, in the class, right? Because as teachers we do understand that that 1 hour or maybe 40 lectures or 50 lectures for one subject, one semester is not enough if we want to really impart education, right? So this will help in understanding more, and learning can be better. Now we move on to the third quadrant, which is a high-tech and student-centered quadrant. So you can see there is a personalized learning. So this is where we are moving towards in today's world, right? This is where these educational people, they do say now that if you have to really make the learning effective, it should be personalized in nature. So personalized is like, as a teacher, I am catering to every student's requirement, right? So because I would see that I would categorize students into two categories. So one would be a very active, a curious student, and another would be a lazy student, right? So every student is no student is like nahi nahi isko to karna hi nahi. He can be lazy, right? So you would find that if we cater to his own needs, right? If we cater to, maybe he is lazy because he doesn't understand the concept. So if we cater those needs, we can really enhance the learning quotient of the student, and that is what is really has to be done going forward. So personalized learning is still an evolving model, because then there is constantly there is growth in this kind of a model, and you have dedicated plans of learning and assessment for each student. So it's like, maybe the examination level would be different for different students. So an active learner and curious learner who has a good knowledge, he may be having an exam where the level of questions may be higher, whereas for a student who is not very active and he is still at a very basic concept level, he may be taking that course on his own pace, right? So game based learning is this is very interesting, and there is a reason why I want to focus on this quadrant, because in today's world we talk about OB. So NBA, that is National Board of Accreditation, is certifying institutes based on how well they disseminate OB, right? That is outcome based education. So we are focused as educators, we are focused towards the student needs in the tomorrow's world, right? So tomorrow's world is like when you actually work in your career. So how can you relate what you have done in your laboratory, and how can you actually implement that task that you have done in your laboratory in your career, right? So it would be a good 4 or 5 years down the line when you will be actually working with those things or those instruments, right? So how do you make sure that, okay, whatever you have learned, you have learned from an outcome based perspective, so that you can operate that instrument or handle that glassware very comfortably during the first day of your job. So this is the quadrant where we all are as educators, and as students also, you would be very focused towards. So game based learning is like video games. So PUBG was very popular before it got banned. So you would find that when you certainly cross a particular level, you would get awarded with some badges, some score points, some guns, or something like that, right? So what we are getting is, as soon as you cross a particular level, or you complete a particular task, you are awarded with some levels or some badges, right? That basically tells, okay, when I compare 2 students or when I compare 10 students, I would understand what is the growth of a particular student in a particular subject, right? So it is more of fun kind of learning, right? So it intends to have more engagement in the classroom. And of course, when we are talking about a game based learning experience, you would find that there has to be significant amount of time that has to be incorporated by the faculty into preparing the kind of delivery that is required. And because it is teacher planned methodology, it is not completely student centered, and that is why you would find that personalized learning is on the right hand side and game based learning is on the teacher centered. Of course it is on the student centered side, but it is not as on the right hand side as personalized learning, right? Next is inquiry based learning. This is another interesting perspective wherein we actually learn by doing things by our hand, right? So inquiry based learning is like you doing your projects, right? So you go in depth, study about things in depth, and teacher is basically a mentor or a support figure where he's going to guide you in wherever the problem comes, right? Or wherever the concept is not clear with what you need to do or how you need to do it, right? So inquiry based learning is problem approach. Okay. Then there are low tech but student centered approaches, right? So student centered approach, number one is expeditionary learning. So expeditionary learning is like say for example this is more project like learning, but then there is a difference, like say for example a student is doing research on what happened in Chernobyl in Ukraine, right? So Chernobyl was a nuclear disaster that happened in the past century. So if he wants to learn as to what needs to be taken care of and how that disaster went out, so what he'll do is he'll do first literature and in-depth analysis about how things happened, and then he will go out on an expedition, maybe he with his group of students or maybe with his support with his student group to actually to Chernobyl. So I'm just giving an exaggerated example, but then he'll go and see what after effects the nuclear radiation has caused on that area, right? What is the population that is residing in that area, how people have lived after what has happened, and maybe if he obtains permission, he can go to that area and visit as to what exactly happened and how it changed things after course. So it's like moving out on an expedition, right? And the last is differentiated instruction, right? So differentiated instruction is more of a personalized learning kind of a learning method, but then you can see differentiation is there. So it is again student centric because it is going to be student oriented, but then the technology side the technology that is used is lesser when we compare it with personalized learning, which is an high tech end, right? So these are all the different quadrants, and I would certainly put virtual labs in this quadrant when the learning is personalized in nature, right? You get you really have fun while learning. The simulators are really fun because you actually get to view all that you see in a lab, right? So a very good content developed would make you see everything that you see in a lab, and maybe if the content is really nice, you would also see a person, maybe a boy or a girl who is handling the apparatus, and maybe you can relate to that guy or girl as you own self, that you are handling the pipette, you are handling the burette, and you are emptying it into a beaker, and you would visualize it like you are doing the experiment on your own. Of course, you are operating it using a mouse or a keyboard or a joystick, something like that, but then it will make you feel like that. So the reason why we wanted to study this these four quadrants, and especially this quadrant, is like virtual labs is in this high-tech student-centered quadrant where each and every student can have a personalized learning experience, which is of course fun, and then you obviously get to see some problem-based content also being developed. So of course the labs have to be developed with a particular orientation, and there would be some laboratories where you would be exposed to certain problems, and then you have to come out of that problem, right? So this is why I wanted to specifically get into these methods of teaching, right? So now before we actually understand Bloom's taxonomy, what is cognition? So हमने बोला cognitive skills, we talked about cognitive skills, right? So cognition is the process that I was talking about. So we see something, right? And we see that okay चोरी हो रही है, and then we process it in our mind and we say that okay we should call the police. या फिर if someone is beaten up, we see it and process in our mind, और देखने से लगता है कि ठीक है मारने वाला आदमी इतना हट्टा कट्टा नहीं है, so I can take care of him, and then you say okay I'll go and fight him. And if there are 4 or 5 people, what you do is you don't get into that fight. What you do is you call the police, right? So that is the cognition process that is happening in your mind. So it is a mental action or the process of acquiring knowledge and understanding through thought, experience, and senses. So experience is coming into picture. So हो सकता है you have seen someone पहले झगड़ा हुआ था and then someone got into it और उसको भी बहुत पीट दिया. So something that you have learned from that experience, and you have employed it if you find a similar condition forward. So So we all know that we learn through experiences. So if you have somewhere broken a glassware, or you have damaged the instrument, you would be extra careful the next time, because you know how that had happened, right? So you know one method going to happen, right? So when we talk about Bloom's taxonomy, so this is how we make objectives, which are very important to draw out before actually I design a lab, right? So Bloom's taxonomy was set up by Dr. Benjamin Bloom. So he was an educational psychologist, right? He gave this taxonomy in the year 1956, and the contributions were made to the classification of educational objectives. So how do you classify what the objectives are of education, right? So what was the idea in making this Bloom's taxonomy? The idea was to promote higher forms of thinking in education, such as analyzing and evaluating concepts, procedures, and principles rather than remembering the facts, which is rote learning. So I'm sorry, we touch upon this in the next slide, right? In the year 1956, Dr. Benjamin Bloom came up with Bloom's taxonomy, but in the year 2001, there was a revision that was done, right? So a group of cognitive psychologists, curriculum theorists, and instructional researchers and testing and assessment specialists. So everyone who is involved in educational technology, they came up with a revised version of Bloom's taxonomy. And there was a paper that was published, that a taxonomy for teaching, learning, and assessment, and they slightly changed the levels of cognition. So you'll see the modified Bloom's taxonomy, on the basis of which we design a virtual lab or design a content, right? So this has already been taken by Norona sir, but then let us try and see how we relate this with the lab, right? So just as when we enter a laboratory, there is an aim that you find out on a manual, or maybe the faculty will tell you before we start a particular experiment. So there would be an aim in the same manner, but then the aim is further going to be divided into LOs, or learning objectives, right? And how do we make learning objectives when we are designing a virtual laboratory, or when I am asking, or when I am teaching you how titration is done? What are my learning objectives going to be? So I should be having this in my mind before I start telling you how to perform the practical. So you can see there are different levels of cognition stated here. We'll try to break it down into how we actually do the experiment. So let us say we want to do titration, for example, right? So there are chances that the practical that you are doing is correlated to the theory that you have, right? So it is very obvious that you must be knowing what titration is. So what you do in the first stage, jaise titration ka naam aaya, you start remembering what titration means, right? So remembering would include defining something in your mind, right? Duplicating something, listing down what are the apparatus which is used. So repeat. So this is the rote learning stage that we are saying. जो याद है उसको कोशिश करो recall करने की, right? And then based on that, we try and understand things, right? So say for example, there is a fan regulator, and you have seen the regulator, and you know that regulator को 1 से 2 पे move किया, so you know when I move that 1 to 2, the RPM of the fan is going to go up, right? So that is understanding a concept that as soon as I increase the current that has been given to maybe the coil that is there, my fan speed would go up, right? And if I take it to 5, it would be really very high, and if I take it down, it would go down, right? So this is understanding that, okay, if I increase this, the fan speed would increase. So that is understanding, right? Now we apply that. So when I know this, that we as small kids, we don't know, right? हमें कोई सिखाता नहीं है कि इस तरह से. So what we generally do is we learn by watching, right? So we learn that, okay, our parents are moving the regulator on the right side, it increases, on the left side it decreases, right? And a lot of times you would find कि zero हो जाता है and you don't know what to do, right? Of course we'll not remember this because this is very infant stage that I'm talking about, but then we learn by seeing, right? And when you understand that, okay, the right is increasing the speed and left is decreasing the speed, you apply it, right? And apply it, and then you see the results. Okay, if I'm turning it to right, it is increasing the speed. If I'm turning it to left, we are decreasing the speed. Now the fourth stage. So this is very obvious in the lab experiments that we see, right? So when we go into the fourth stage, that is the analyze, this is where the higher level of cognition start coming up, right? So analyze level is like, say for example, you do not have 1, 2, 3, 4, and 5, right? So analyzing would be, okay, let us say that we have these 5 switches in the regulator, and when you take it to 1, let us say you have a machine to record the RPM. So 1 pe leke gaye and the RPM was around 500 revolutions per minute. You took it to 2, the revolutions per minute went up to 700. If you took it to 3, the revolutions per minute went up to maybe 900. So you can now understand the correlation. That is what you are analyzing. So what you are doing is you are drawing connection among the ideas. So this is what you are analyzing, right? So say for example, if you are doing a process, if you are cooking food, you would understand that okay, when I cook food at say for example for 20 minutes, it gets cooked properly. If I just keep it for 18 minutes, it still cooks properly. If I take it to 15 minutes, it doesn't cook properly. So I know that 20 may be too high. I'm wasting 2 minutes of my LPG gas, and 15 would be too low, right? So if I am a smart researcher, I may try it at 17 minutes as well. So I try to find the threshold value below which I would get uncooked food, right? And I'll try to implement it from the next time in my cooking activities, right? So that is analyzing. Now evaluating is like you have multiple sets of data points, right? Say for example, if there is a chemical reaction that is going on, say A plus B gives C, right? And there are two conditions or two parameters that you are handling, say temperature and pressure, right? So the process has to carry out at let's say for example, you want to find out the right setting of temperature and pressure for the process. So it's अगर एक ही चीज होती तो you would have been very, so temperature 100 degrees, okay, there is a problem. Let us say we go to 50 degrees, okay, there is a problem. We go to 150 degree, okay, it is becoming better. Then you go to 200 degrees, it is becoming much better. 250, yeah, perfect, right? So these are 5 points that you have reached. So you have got some values, you have done some testing, and you know, okay, 50 से लेके to 50 degrees तक, these are my values that I'm getting. Now let us add pressure into that mix. So there would be now a combination. It would not be okay, I take it to 50 and I take it up to 250. So there would be different combinations based on the statistical probability that you would see. And then you find out that okay, with the combination of say X pressure and Y temperature, I'm getting these results. Say X plus 1 temperature, Y pressure, I'm getting these results. And then you would correlate all the data points or the data sets that you have gotten, and you would try to get the right temperature and pressure for conducting the process. And that is what evaluation means. So you justify a stand or a decision. Now whatever you have learned, so it is very difficult to understand before remembering. It is very difficult to apply before understanding. It is very difficult to analyze before applying, and that is how we do it in a practical, right? And the topmost level is the create level. So this is what has changed during the modified Bloom's taxonomy, right? So create is like, now you know that the temperature and the pressure conditions are this, and this is the vessel, and I want to cook something which I have not cooked before, right? So you know everything now, and now you will cook that dish. That is what create means, right? So you know all the basics of whatever designs are there, and then you plan to create a new reactor, right? So that is something which is expected out of every student that passes out in his or own career. That is what is expected in the industry. So whatever you are learning within the college as a student, you would be expected to perform in that, and you would find out that create level is very important for the company. The company that you are in, because they want to stay competitive in the market, and they can only do it by continually developing new products, right? So maybe it can be a copy of something that is available in the market, but then even there, the product is going to be new for your company, right? So that is going to be a reverse engineering process. So it's very obvious now to understand that नीचे से ऊपर जाते हुए, the level of difficulty keeps on growing, right? Yeah. So a couple of slides more. So Bloom's taxonomy for cognitive skills. So objectives or learning goals are important to establish in a pedagogical interchange between the students and the teachers, so that both alike understand the purpose of that interchange. So it is very important to understand from the student perspective and the teacher perspective as well. So teaching, learning, when we are talking about in engineering, it is very important to learn these things from both the student perspective as well as the teacher's perspective. So teacher should be very clear in his mindset as to what my objective is going to be with this class. A student should be clear, of course, with the help of the teacher, he would understand that, okay, this is what we want to learn during our class. So a nice way of starting off a lecture would be to just introduce the topic and tell the students of what to expect during the class. Organizing these objectives help to clarify it for themselves and for the students, and having an organized set of objectives helps educators or faculties to plan and deliver appropriate instruction, design valid assessment tasks and strategies. So this is very important. So you would find that in today's world, formative assessment is gaining its space. So you would find a lot of assessment methods are actually used in class before you take the class test or midterms or semester exams as to whether or not the students had actually understood the topic that you have delivered on that day. So if you have a set objective pre-made before the class, you would be able to understand how do you understand or how do you assess the students and ensure that the instruction and assessment are aligned with the objectives, right? So make sure that you are not going off the path, right? Okay, now what is going to be the benefit to the students and the stakeholders? So this is what we have already seen in most of the institutes, and we started off with our own institute. So what happened, what used to happen before was there was conventional way of performing lab sessions. So the ideal way of doing a lab session would be there would be a group of 10, 20 or 30 students in a batch, and so that there can be more individualized learning. But then you would often see that probably a couple of students will be, or maybe 4 to 5 students will be handling the lab setup, right? Because I mean they are the ones who are more curious, more more proactive, you can say, right? And then of course there would be a lot of visual learning by the other students, but then it certainly doesn't reach the same level for each and every student. Now after you implement virtual lab in your institute, you get an advanced methodology with the use of virtual laboratory. So now what you can do is you can you would get it in the next point. So some lab sessions were carried out in groups, and then now with the virtual lab simulator, all the students, if they have a mobile phone or you have a central lab facility where all the students of your batch can sit, they can take the simulator. So it's like it's not necessary that you can, if you are taking a practical hands-on, you cannot take a virtual lab. You can take a virtual lab even if you are taking a hands-on practical, right? So theory teaching was largely centric to the lecture hall. So lecture hall se bahar, and then the lecture is over. I mean, you do not dream or think about what happened in the class, right? For a majority of the students, right? Now what happens is because things can be done outside the lecture hall, maybe in a mobile phone or a laptop or a computer. So this has led to theoretical learning at the own pace with an increase in the curiosity levels. So once the students understand, the ones who are not able to do it in the class, once they do it by their own hands, they would be able to understand, okay, when the current is increasing, maybe when the voltage is increasing, the capacitance is going up. When the voltage is going down, the capacitance is going down. So why is it happening? The student will try and understand that, will try and identify that by asking you, by doing a search on quick search on Google or something like that. So as an extension to traditional teaching methodologies, audio-visual methods were adopted earlier. So maximum PowerPoint was something that was used earlier, and with simulators, the learning was enhanced due to its interactive nature. So simulators, so a PowerPoint lecture going on and the faculty telling you something doesn't ask you anything, right? So if the faculty is keen enough, he would ask you questions. Okay, ye samajh mein aaya. Did you get this? Why does this happen like this? Right? But then with simulators, what will happen is the simulators will keep on asking questions because the content has been designed in a manner where the simulator is touching upon all the different levels of Bloom's taxonomy, right? So conducting mistakes was costly or could lead to accidents during laboratory-based learning activities, whereas the features incorporated in content designing allowed students to learn by committing mistakes. Say, for example, if you are doing a program in nuclear physics, let's say, a very specified branch, let's say a master's in nuclear physics, and then there is one basic nuclear fission reaction that you need to conduct, and you have a prototype. So the institute has a prototype. So what you have to do, so this is basically class 12 chemistry. So you look out the cadmium and the boron rods, and then there would be bombarding of uranium-235 isotopes. And because of that, a lot of energy would be created, and there would be a coolant that would be passing through the reactor, reactor internal side, and the coolant would exchange the heat, and that is how you will generate electricity from steam that is coming out, right? So a faculty would not even dream of allowing you to handle this experiment, because if the experiment goes wrong, I mean, life is at stake, and not just you, probably kilometers of people who are living within your place, right? So you can do that experiment on a virtual lab. Let it go boom. It is fine because nothing is happening actually. So then, while doing this, you can learn by doing things wrong, right? So there is an aspect of learning by doing. There are other two aspects by learning by listening and learning by watching. But then you actually commit a mistake. and you will not insert the rods even after the process is stopped, and then there would be too much heat accumulation, and then the reactors would blast. So you can actually do it when you have a simulator kind of a setup, which is actually not possible at all in a physical environment, right? So the idea why we had gone through this pedagogy presentation to understand about virtual laboratory is that whatever we have discussed here, everything that we have discussed here is well understood while designing a virtual laboratory simulator. So the faculty's role in content development is like taking care of all the aspects that we have discussed here and incorporating it in the simulator so that learning can be enhanced, right? And that is what is the basis of a virtual laboratory simulator, and more so of content development during the design stage, right? So that would be it from our side. You can reach me at my given ID or virtual lab manager website, right? And I thank you for the opportunity. I know I am standing between you and the lunch probably, so I'd just stop here, and I'd give it back to you, Dr. Saab.
Thank you, sir. Thank you very much for giving the importance of Bloom's taxonomy and the teaching learning pedagogy, not only for the teaching, for also for the virtual labs. I'm extremely thankful, you, sir, to you and to Abhilasha ma'am for your valuable time, suggestions, and for being with us from the day we have been become a Nodal center. Thank you, ma'am.
Thank you, sir.
Now,
Thank you, sir.
Now, as per the schedule, now the session will be having, we'll try to have a hands-on virtual lab demos for various disciplines. Let's start with the basic subject, physics, mother of all subjects. So now I request Dr. Gagan Bihari, sir, are you there?
Yes.
Yeah, so now I request you take the session and give a demo for hands-on virtual lab. Over to you, sir.
Okay. Thank you, Dr. Ugandar. I hope all of you have gone through this. What are the benefits of this virtual lab? So now I'm going to demonstrate to you one of the optics virtual lab experiments. So to do that, what I'll do, let me share my screen first. Okay, so I'll go to this browser and search www.vlabs.iitb.ac.in. This is the place where you have to enter. Just 1 second. I don't know what's the issue here.
So check whether you are signed in.
Yeah, I'm just checking that one only.
Next step.
Yeah, it's connecting. Okay, so I just browsed that vlabs.iitb.ac.in. Now in this page, if you scroll down, you'll see the disciplines and domain. You'll see different disciplines like electronics and communication, computer science and engineering, electrical engineering. Then you have mechanical, then chemical, biotechnology, and you have physical science. And I'm going to demonstrate to you one of the experiments in the virtual optics virtual lab. So what I'll do, I'll go to this physical science branch. Once you enter there, you will see there are a lot of different parts like virtual astrophysics, molecular, solid state, and so you can go through all of these. So what I'll do, I'll go to virtual optics lab, since I'm going to demonstrate you one of the experiment. And now I'll go to, in this page, you have large number of experiments. So I'll go to the simple one, that's angle of the prism using spectrometer. So you can see here in the first page itself, the theory is given, and it's given what is the aim of this experiment, what we are going to do. And the aim is to determine the angle of the given prism. Then for that, what are the apparatus we need? It's already given here. You can see all these: spectrometer, prism, then magnifying glass, sodium vapor lamp. Then the principle is given here. So I'm not going to discuss all these principles here. So mainly I will discuss how to perform the experiments. So this is what the theory, you can read this. Then the next one is the procedure, how to perform the experiments. The step-by-step guide is given here. So you can just go through this one. First one is we have to switch on the lights, then place the prism, then we have to change the slit width, then rotate the telescope, and all this process you can just go through here. And then you just have to find out the list count of the spectrometer, because you are going to use the spectrometer to perform the experiment. So to find the list count, the formula is, it's given here. You can note down this. It's the one main scale division L divided by number of divisions on the vernier scale. So that's what is given here. That will give you the list count value in the minute, in the unit of minute. So this is the procedure. You can go through this. Then once you go through this one, there is something called self-evaluation. It's just it asks several questions to you. If you go through the theory part, you can do this one. Then directly I will go to the simulator part. So let us see here in this. Okay, it's saying my flash player is enabled. So what to do that? Just go to the not secure page, then go to site setting. Most of the time it asks for that one. Then you just have to enable your flash player. So I'll just enable this one, and then go to the virtual lab part. Okay, then it will load this spectrometer experiments. Okay, it's just loading. Okay, now you have this one. So you can see this is your spectrometer. Then you have the collimator. Then you have the telescope. You have some prism table here. The first part here is we have to focus the telescope for the last distance. So here you have an object. It is showing here. Then to do that, in this place, if you follow the mouse pointer here, you have to start this one. Now if you see, the start button is not enabled. So first part is we have to focus the object. So I'm just changing this one. Yeah, now you can see the object is focused. Once that one is over, your start button will get enabled. Then you can put the start button. So you can see here you have the spectrometer whole setup here. Then the next part is we have to switch on the light. Once you switch on the light, you see there are some lights here. Now the next one, what you should do is you should change the slit width, because you need a focused narrow beam. So I'll just change this one. Yeah, I'm doing that one. So you can see now it is focused. You can do some little adjustment also. Then the next part is we have to place the prism. You can see here, place the prism. Just click on that one. Once you place the prism, you have a source here. That is the light source. Then you have a collimator, and light falls in this surface. In this prism, you have two reflecting side, and this one is the opaque side. So once you place the prism, you do not see any light here. The next part is we have to rotate the telescope to find the reflected beams. So either you can hold this prism directly, you can hold the telescope directly rotate, or you can change angle. You have something called change angle, that is the telescope. So you can rotate this. So in one side you can rotate. Now if you rotate, at some point we'll able to see the lights. Okay, once you have this light, you have focused the light, then we have to measure the readings. How to do that? If you see here in this, you can see the readings here. There are two scales. One you can see the upper one and the lower one. So for each position of the telescope, like for this position of the telescope, we have to note down the reading from both the scales. Now, if you see here in the upper portion, I can see the readings. Then we'll note down these readings and then put it in the observation table. In the observation table, you have something called left hand side and then you have right hand side. Now what this tells us, or you say this was our original position of the telescope. If you remember before the or I'll say this was the original position of the telescope. Now I am rotating this to the left side. So I'll take this reading as left hand side reading and then focus on this light and then try to note down the readings. So I'll focus on this one. I'm taking left hand side. Since there are two scales here, we'll give some name like vernier 1 and vernier 2. Now the next part is how to take the readings. Now I have shown the magnified version. Now in the left hand side reading, you have something, if you observe the observation table, you have called main scale reading, then vernier scale reading, and then total. Then next part is how to find the main scale reading. At this position, now see which line or the which value of the lower scale. If you see the scale magnified version, there are two scale. One you can see 120, 130 and so on. Then the upper one it's written 0, 10, 20 and 30. So to find the main scale reading, find out which readings of the lower scale coincide with the 0 of the upper scale. So if you see here, between 120 and 130 there are 20 divisions. So I can say 2 divisions is equal to 1 degree. So if I look at these readings, it's coming as the main scale reading is coming as 120 degree at 120.5 degree. Okay, then the next one is vernier scale reading. Vernier scale reading is nothing but the vernier constant into least count. And if you calculate the least count of this instrument using that formula, you'll find that the least count of this setup will turn out to be 1 minute. Then to find the vernier scale reading, we have to find the vernier constant, then multiply that with our least count. That will give us the vernier scale reading. Now how to find the vernier constant? You have to find out which readings of the upper scale. In this scale you have one is lower, that is 120, 130, 140 and so on. The upper one, as I said, 0, 20, 30 and so on. So find out which readings of the or which value of the upper scale exactly coincide with the lower scale. So that's what will give us the vernier constant, and then multiply that with the least count, that is 1 minute. So that will give you the reading in the minute, and the main scale reading we have noted in the degree. So to find the total is nothing equal to MSR plus VSR. So what we have to do, since one is in degree and the other one is minute, you convert the minute into degree or degree into minute, then add it. That will give you the one of the vernier scale reading from the left side. Then at the same position, we have to note down the reading from the upper one, the second scale. That is, we say the vernier scale. I'm just focusing that one. So that will give you the vernier V2 reading. So you can say V1, then V2. And here you can see the main scale reading, the which value of the lower scale coincide with the 0 of the or close to the 0 of the upper scale, and that will give you can see here, it's close to 300. So that you can note down and put that in the main scale in the vernier 2 main scale reading. Then note down the vernier scale reading and find out the total. This is from the left side. Similarly, what we should do, we have to rotate the telescope to the other side. This we are saying in the left side. Then I am taking this to the right side. And then I'll try to focus where the reflected beam is. So I have to focus it with the vertical line of the crosshair. Now we have the right hand side light, and then note down the reading. Again, you have to find out this is the vernier 1, and then this I have taken as vernier 2. So these are just the naming. You should remember this. One thing is, whether you are in the left side or the right side, if you are taking this scale as vernier 1, keep this as vernier 1 for the whole experiments. That's the thing you have to keep track of, and then find out the readings. And it is close to 240. So your right hand side vernier 1, I'm saying it is close to 240. Actually it is 240.5. That's the main scale I'm talking about. Then similarly, you find out the vernier constant from this one, and then find out the vernier scale leading and find out the total, that is equal to MSR plus BSR. That is from the vernier 1, and then go to the other vernier. Since there are two scales, note down here. That will give you the readings for the right hand side vernier 2. So it is close to 60. That is the main scale reading. Now you have noted down all the readings. Like when you were in the left hand side, you have noted the readings from the vernier 1 as well as the vernier 2. Similarly, while you were in the right hand side, you have noted down the readings for the vernier 1 and vernier 2. Then the difference between left hand side vernier 1 and right hand side vernier 1, that we have to keep track. The difference between the left hand side vernier 1 and the right hand side vernier 1, that will give us twice of the angle of the prism. So the difference, if you measure, as I say, in one of the readings we had 120.5, that the left hand side vernier 1, that's the main scale mainly I'm talking about. Similarly, the right hand side reading, it is 240.5. Now if you take the difference, that will give you twice of the angle of the prism, and so if you take the difference, it's coming as 120 degree. So 240.5 minus 120.5, so it's coming around 120 degree, and just from there you can find out the angle of the prism is 60 degree. So from this experiment we can measure the angle of the prism by following these steps. Now once you are familiar with how to take the readings using the spectrometer, then you can perform other experiment also, like find the refractive index of the different color, then find the Cauchy's constant. So this is the basic part that I explained, how to find the means how to use the spectrometer to find out the readings. And I hope all of you can do this experiment. If you are following this, you can actually open your laptop or desktop and then do the experiment yourself. So this is how you have to perform the simple experiments on how to measure the angle of the prism. Okay, so now I hand over this to Dr. Yogendra.
Please start here. Thank you, Dr. Jaydev. Sorry, Dr. Gagan. I'm really sorry for a nice explanation for the prism experiment. So, okay. So I would like to just take you skimming of the crystal structure in physics. Okay, these are helpful in explaining the various crystal structures in the condensed matter physics, the first chapter. So let me start share my screen. Hope I am audible. All of you can see my screen also. People, if you are having your mobile or any desktop or laptop, you can also parallelly do along with us, so that you will have a real experience of hands-on sessions. So now in the Google, I'm going to just type virtual labs. Okay, so you will get two things. In the first, you can go the virtual labs, or you can go to the IIT Bombay virtual lab. Anything you can go. Okay, so you can also go through this virtual lab. So here, if you see the first page, in the first page, it's an initiative by Ministry of MHRD. If you see the broad areas, you can go to the physical science. So in the physical science, again, in this discipline, you have a lot of labs corresponding to various sub-branches of physics. So we have just now seen in the optics lab. Now let me go to this solid state physics virtual lab. Normally for explaining these crystal structures and all, so here you have a crystal structure, crystallography, crystal structure, a unique arrangement of atoms that will explain you how the atoms are arranged inside a unit cell. I just clicked on the crystal structure. You can also do the characteristics of a xenon diode, gauge curve, resistivity, and the Hall effect is also there. A very nice experiment. It's taking some time. Let me go this way. Okay, so the crystal structure, as the aim suggests, you need to understand the various crystal types. There are basically 7 types of crystal structures. It is the arrangement of atoms inside the lattice. So theory, I'm not going to it. You can see the procedure over here, or you can always directly go to the simulator also. So you just need to select the crystal type which you want to give a demo to the students in your class. This you can do then and there while you're teaching in the class also. Previously we used to have a well-built models, so which you need to carry the class. Now you don't need to do, all you need to do is open your laptop and connect to this virtual lab so that you can have a demo. So choose a corresponding crystal type. We know in the 7 crystal systems are subdivided into 14 Brevets lattices. So you choose that particular type of atomic arrangement. Then you can see I'm just going to the simulator. So yeah, this one thing which I would like to explain here. Once if you click this, it will ask you to log in. So those who are not registered with the VLab, you can register with this. This is a centralized login. So once if you log in, so I already created. If you have not created your login, I kindly request the participants to create your login. You create an account here at the bottom by clicking this. So since I already created, I am just using my, okay. So now you see, it will ask you again, you need to enable the Flash player. So please do install the Flash player. If you are doing parallelly with me in your mobile, you may face some difficulty, but try to do either in the mobile or your. So all you need to do is, since I already installed, so go to this left side, you just put Flash, ask default. So here you need to just allow. Once if you click on allow, it will ask you to reload. So just reload this. The Flash player will reload. Now you can see the crystal structure. So here you can have the 7 crystal systems. So let me take the cubic. So in the cubic, so this is your simple cubic. The cubic is defined as where alpha, beta, gamma are 90. These are called as the crystal parameters. So these are called as the lattice parameters. These are called as the lattice angles. So if the length A, B, and C are equal and alpha equal to beta equal to 90, you see this is a simple cubic where 8 atoms are sitting at the 8 corners. If you take similarly for the body centers, you can see there is 1 atom at the center of the body. So this you can see, you can always rotate in the 3 dimensions. So now you can explain the students in, very easily. You can show all the types. You can see the face centered. Face centered, it is defined as the 8 atoms at the 8 corners, plus each atom sitting on each face of your cube. So this is your simple cubic. So you don't need to have any softwares. Normally, if before the virtual lab, whenever I used to explain to students, I used to use the software called as a crystal demo. Those who are in the physics discipline, they might be knowing. So either use the crystal demo or the Whisper software to show these type of crystal structures to the students. Okay. Now with the help of this virtual lab, you can demo all these, type of crystal structures. Okay. So you can also see the transparency. The transparency also you can change whether you want only the particular lattice constant values. You don't want to see the faces. Okay. Or you can also choose this. So this will different colors are given. The blue is the left side, and the yellow is the back side of that, and the green is the right side the face. So the three faces, you can say the three lattice constants, the A and B and C. So this is all about the how to do the show the crystals to the students in online. You can always do various other experiments in not only in the condensed matter physics. You have a Hall effect. This is also a very nice experiment you can always do. And with the help of this log, you can do the two things. One is you can always calibrate the magnetic field for a given amount of current. How much magnetic field is produced for a given amount of current. Then you can also perform the lab Hall effect experiment. You can find out the Hall coefficient or Hall voltages or the type of charge carriers. So these are only the two, three things that we try to explain. But if you would have time, would have explained a lot of other things also, like a xenodiode experiment on many other things. It is not opening. So with this, since we are already running out of the time, now I'll hand over the session to the next speakers, who belongs to the Electronics and Communication Virtual Lab. Sir, are you there? Abhijit sir? Abhijit sir? Sir, I have made you co-host.
Sir, my voice is audible?
Can you increase little bit, sir?
Yes, sir. Just a minute. Sir, have you made me the co-host? Actually, I'm unable to unmute myself. That's why.
Yeah, I made you, sir.
Yes, sir. Just a minute. 1 minute.
Your
Very good afternoon to all the participants. I would request the participants to please comment on chat box as is the voice audible.
Yes, sir, your voice is audible.
Okay. Good afternoon, everyone. My name is Abhijit Pathak, and I'm from Electronics and Telecommunication Department, Jabalpur Engineering College, Jabalpur. On behalf of Jabalpur Engineering College, I again welcome you all. So in this session, we will have a demo of virtual labs for Electronics and Telecommunication Department. Many of the students would be belonging to EC. Many of the participants would be of EC department. Students from EC department are there. Please reply on the chat box so that we can interact more. Yes, okay. So the purpose of today's session is to give a demo how virtual lab is useful for Electronics and Telecommunication Department. We will be particularly covering digital electronic circuit lab for the session. I hope most of you will be aware of digital electronics basic fundamental gates: AND gate, NOR gate, AND gate, NOT gate, and AND gate. Probably we have first year, second year students. Most of you would be familiar to AND gate, NOT gate, basic logic functions. Okay, so I'll be sharing my screen. Just a minute. Okay, is my screen visible to everyone? I've started sharing the screen.
Yes, sir.
Yes. Okay, fine. So first of all, again, I would like to introduce you to the way we have to enter virtual lab. Although Yukanta sir has already done it, just simply write on Google VLabs, okay, and just enter. We then go into the first address, vlab.co.in. Just click on it. Now we have this opening page, Virtual Labs Initiative of Ministry of Education. Okay. Since we are having a demo of Electronics and Telecommunication Department, scroll down, go to broad areas of Virtual Lab, and just click on Electronics and Communication, our department. So, as you enter Electronics and Communication Department, there are a lot of labs available right now, and some of the labs are under development. The labs which are ready for use are digital application lab, digital logic design using gate, digital logic design, fading channel. Means this virtual lab has covered almost every domain of electronics and communication, and it is also getting updated. There are certain labs under development, and very soon we will be having that labs also fully ready for use. So today I will be giving a demo of digital electronic circuit lab. As you can see on the screen, this is digital electronic circuit lab. I will be giving a demo of digital electronic circuit lab. Just click on digital electronic circuit lab. This lab is developed by IIT Kharagpur. I would like to inform that this particular digital electronic circuit laboratory is developed by IIT Kharagpur. So as you just click on digital electronic circuit lab, you will be heading to a page like this. Welcome to digital electronic circuit laboratory. Okay, you can see introduction, list of experiments, people, feedback, technology used. The home page contains all these tabs, as you can see. So today, first of all, as you must, first of all, you should be aware of what is digital. Okay, what is a digital signal? It has only two values: fundamental knowledge, only two logic levels, either 0 or logic 1, and fundamental knowledge of logic gates. Like we have three basic gates: and, or, and not. Okay, and a truth table about it. This is quite a prerequisite. I hope everybody is aware of it. Now we will go to list of experiment. We are choosing any random experiment, just a basic experiment to have a demo session. That is analysis and synthesis of basic experiment number 3, analysis and synthesis of Boolean Boolean expression using basic logic gates. Just click on experiment number 3. I hope everybody is familiar with the process to enter. This is probably third time we are entering this lab from the morning session. How to enter any particular lab? It's almost similar as a lab would be in an offline era, that normal era that we had before COVID, pre-COVID. You used to enter to the college, and you used to enter to the department, then you used to enter to the particular lab. Same thing is here. We have entered virtual lab homepage. We have entered electronics and communication department, and then we have entered a particular lab, that is digital electronic circuit lab. Okay, after that, when you enter the lab as in a offline system, when the things were all okay, we used to go to a particular kit in which we have to do the experiment. Every experiment was having a kit. So similarly, we need to go to a particular number of particular series of experiment. So we have entered a particular experiment number, analysis in experiment number 3, analysis and synthesis of Boolean expression using basic logic gates. Here you can see we have introduction, that what after this lab, what you will be able to learn, then what how at the end of this lab session you will be able to analyze the logic gates. You will be able to express Boolean expression using logic gates. You will be able to check equivalence of two Boolean expression using logic gates. And these are the at the end of this experiment, this lab exercise would enable you to do the following. Like in the we have a lab manuals when we were in the offline system. Here also we can have a we have a theory related to this particular lab. Okay, this theory gives an idea of what we need to do in this particular lab exercise. Okay, so as you all know, our basic logic gates and, or, and not. Okay, we are start considering some basic logic gates and some NAND and NOR universal logic gates. Every logic gate is made up of transistors. You all would be aware. What till now what you have studied, or if you are in the first year student or second year, third semester probably student, you would be knowing that you have studied the block level. Okay, now that block level logic diagram of an AND gate, NAND gate, NOR gate, NOT gate, whatever, basically inside that block, inside that box, we have a lot of transistors. So please remember, every logic gate is made up of certain number of transistors. Okay, this is a fundamental knowledge. Every logic gate is made up of certain number of transistors, which we represent in the form of some symbols, which we used to study in our books, in our theory part. Now, every logic gate is available in the form of IC, integrated circuits. IC stands for integrated circuits. Our logic gates are always available in the form of IC. Like suppose if you go to market and you say, okay, I want to purchase an AND gate. No, that is not the correct way. You need to purchase a IC for AND gate. You need to purchase a IC for NAND gate. You need to purchase a IC for some NOT gate. Okay, so every logic gate is available in the form of IC. Okay, what is IC? IC is integrated circuit. Means there are a lot of circuits integrated onto a single platform, that is IC. Okay, integration of certain blocks on a single platform. Okay. Now, every IC has a specific number to, like we have our specific name. Similarly, every IC has a specific number, like IC 7400. IC 7400 is a quad 2 input NAND gate. What does this quad 2 input NAND gate means? In IC 7400, we have 4 2 input NAND gates. We have a 4 2 inputs NAND gate. Like number of NAND gates are 4. Every NAND gate is having 2 input. Okay. So we have 4 2 input NAND gates. Now, as I discussed earlier, that every IC is made up of logic gates are available in the form of IC. Logic gates is made up of transistors. Definitely, transistors would require some power supply, right? Everybody agree that transistors would require some power supply for operation. So every IC requires some power. Okay, so we have always a power supply pin in any IC available. Either you go for AND gate IC, either you go for NAND gate IC, either you go for NOT gate IC. Any IC has some a power supply pin. Pin number 14, as you can see in the figure, number 1, IC 7400. Pin number 14 is a VCC that gives you the supply. Pin number 7 is ground. Okay, the power supply is always with respect to some ground potential. Like if we say there's a potential at some point is at 5 volt, that 5 volt is with respect to ground. Okay, so every IC has a pin for power supply. Like in this IC 7400, we have a IC pin number 14 for VCC and pin number 7 for ground. Okay, now as we discussed, like this is a NAND gate IC. Okay, so in NAND gate IC we have quad 2 input NAND gates, 4 NAND gates available. We have 4 NAND gates. 4 NAND gates. Each NAND gate will be each NAND gate will be having 2 inputs. So if you see, pin number 1 and pin number 2 is the input for NAND gate. Okay, and we have pin number 3 as the output for is the output for the first NAND gate. Similarly, pin number 4 and pin number 5 is the input for second NAND gate, and pin number 6 is the output. Now, for the third NAND gate, if you say pin number 9 and pin number 10 is the input, and pin number 8 is the output. Clearly, please clearly look for the IC pin diagram whenever you go for any circuit design. IC pin diagram is very important, which we are discussing. It helps you to enable the connections. It helps you to connect the IC in the correct fashion. Okay. Similarly, pin number 12 and pin number 13 is the input for the second NAND gate, and pin number fourth NAND gate, and pin number 11 is the output. Okay. So this IC pin diagram would be clear to you. So as we discussed, the basic aim of this experiment is to realize basic logic gates. We're looking for some basic logic operation. Now, if you go for objective, like we used to write aim of the experiment, the principal objective of this experiment is to fully understand the function use of logic gates. Okay, this is the basic aim of this experiment. Then we have a procedure as we used to write in our lab manuals. We have full complete procedure. I will be completely demonstrating that entire procedure. So it will be I will be discussing that entire procedure. Then you go to simulator. I hope everybody would be able to see the simulator window. If suppose Flash is not enabled, just click to enable Flash Player. Just a pop-up window will be coming. Just allow. Now you can again click on simulator, and yes, finally again click on simulator. Now you will be able to just a bit slow internet connectivity. Just a minute. Just a minute. Just give me 2 minutes. Finally, yeah. So please reply on the chat box. Everybody is able to see the simulator window, and after in the simulator window, everybody is able to see some ICs, some circuit connection. Are you able to see it? Some IC, some 7404 hex inverter, 7408 2 quad 2 input. Yes, fine. So, yes, the basic first experiment means which I am giving a demo. Okay, we have asked some familiar students, Himanshu, Priya. Okay, yeah, thank you, Himanshu. Thank you, Priya, for replying. Okay, so first experiment which we are discussing here is AB plus A. We need to verify the operation for AB plus A bar C plus BC is equal to AB plus A bar C. Means we need to verify the equivalence of these two operations, like the resultant of AB plus A bar C plus BC is equal to AB plus A bar C. Okay. So first of all, I would suggest you all to just have a truth table of ABC function. Output is one output is AB plus A bar C plus BC, and second output is AB plus A bar C. Just create a truth table which is the input A, B, and C. Okay, output we have one output is Z1. Z1 is equal to AB plus A bar C plus BC, and Z2 is AB plus A bar C. Okay, I hope this much this would be possible for you. AB plus A bar C plus BC. You need to create a truth table. We have a input A, B, and C. Okay, just tell me if you have three variables as input A, comma B, comma C. What would be the number of possible input combinations? Reply in the chat box. If you have three inputs A, comma B, comma C, what would be the possible number of input combinations? Ritika is saying 9. Shekhar is saying 8. Akshad 8. 8. Okay, fine. Yes, exactly. If you have three possible three inputs, you have 8 possible logic combinations as an input combination from 0 to 7. The total number is 8. Everybody agree. Now, just create a truth table A, B, C. Write all the possible input combinations. In the output side, make 2 columns. One column is for Z1. Z1 is equal to AB plus A bar C plus BC. Second column is for Z2. Z2 is equal to AB plus A bar C. 2 outputs. Okay, and try to fill the truth table on your own. Just a basic exercise. And please tell me when the truth table is ready. What you need to do, you need to produce the output Z1 is equal to AB plus A bar C plus BC. Just write the output for all the possible input combinations. Similarly, Z2, AB plus A bar C. I hope you would be making the truth table and writing the output. By that time, I will introduce this particular simulator. See, you have in this particular simulator window, you can see there's a IC for 740 IC for inverter. The name is 7404 hex inverter IC. We have a IC for AND gate, that is IC 7408, that is quad 2 input AND gate. Means you have 4 AND gates in that particular IC. Similarly, we have IC 7432 quad 2 input OR gate, IC for OR gate. IC 7432 quad 2 input OR gate, another IC for OR gate. IC 7408 quad 2 input AND gate, and IC 7404 hex inverter. Okay, so these are the ICs which are presented in this simulator. On the left side of the figure, you can see A, B, and C are the inputs. Okay, on the right and below that we have a battery. Definitely, we need a battery supply that will be given to pin number 14 and pin number 14 for VCC and pin number 7 for ground. And on the right side of the figure, we have Z1 and Z2 as the output. Both the outputs are connected to a LED. You can see everybody is able to see the LED, a bulb, a small bulb which is connected to Z1 and Z2. Everybody noticed it? Z1 and Z2 output is connected to a LED. Yes, that will be denoting our output. Means if the glowing of the bulb will denote that a logic 1 is present at the output, and if the bulb is off, a logic 0 is present. Similarly for Z2. So now have you all created the truth table? Is the truth table ready for AB plus A bar C plus BC and AB plus A bar C? Okay, fine. So now again come back to the simulator. See, current as you can see, what for generating AB plus A bar C plus BC, what all we need to have for generating AB plus A bar C plus BC, we need to have three AND gates. One AND gate would be producing A dot B, one AND gate would be producing A bar dot C, and another AND gate would be producing B dot C. Everybody agree? We need to have three AND gates. We need to have two OR gates for the two plus symbols, that for adding AB and A bar C, and then adding BC to the resultant AB plus A bar C. Also, we need to have a NOT gate that would be complementing A, that would be converting A to A bar. Fine, everybody agree with this? We need to have three AND gates, two OR gate, and one NOT gate, right? AB plus A bar C plus BC. Reply in the chat box. Everybody agree? Yes. So now you see the pin diagram, circuit connection. First, the pin number A, a logic input A is going to pin number 1 of the 7406 hex inverter. At the output, pin number 2 of the 7404 IC will be having A bar. That A bar is being given to the input of a AND gate, pin number. That A bar is being given to the input of the AND gate, pin number, probably. Just reply. Can you see where the A bar is going? We have input A to the pin number 1. Output will be coming A bar. That pin number 2 is directly connected to pin number 12. So we have A bar available at pin number 12. The second input for the AND gate is pin number 13. That is connected to C. So we have generated A bar C. Similarly, we need to produce AB. Similarly, we need to produce BC. All you need to do is first understand the circuit and the pin connection. Everybody is able to see that how AB plus A bar C plus BC is generated. Like for instance, if we check for BC, how BC is being generated. So BC, we need to have B dot C. For that, we will be using an AND gate. That AND gate is being used for generating BC. Similarly, for AC, then we need to OR AB plus A bar C plus BC for producing Z1. So Z1 is the output of of the OR gate, that is using pin number 6 of the OR gate. So I hope everybody would be familiar how it is. Everybody would be now knowing how AB plus A bar C plus BC is generated. Everybody understood the connection AB plus A bar C plus BC. Yes. Similarly, we need to generate AB plus A bar C. Okay. Similarly, we need to generate the second output. Z2 is AB plus A bar C. That would be also the same process. Again, we need to AND A and B, and we need to AND A bar and C, and we need to OR the both the resultant. It is AB plus A bar C. Okay. Now, what is the purpose of simulator? Just this what we discussed is a basic circuit diagram. Okay, how it is being generated. Now, what is the purpose of simulator? Simulator purpose is to check for all possible input combination that the output is being generated and the output is correct or not. Stimulus means for a corresponding input you gave, some output is generated. Simulator window, the basic purpose here is you need to give some logic inputs, and for that you need to check the output. So currently A, B, and C are at 0, 0, 0. If you check, there's a there in the circuit where in the left side, A, B, C all are currently red. Okay, so the A, B, C are 0. According to the truth table which you have created, what would be the value of Z1? AB plus A bar C plus BC. What would be the value of Z1? 0. Okay, so you can similarly Z2 would be also 0. So you can see that Z1 and Z2, the LED connected to Z1 and Z2, both are not glowing, both are in the off state. So So output is logic 0. Now the how to change this logic level? Just click on the red bar of any of the logic input. Just click on red color. It will get turned to C has now converted to 1 from logic 0. C has now took a transition to logic 1. Now A is 0, B is 0, and C is 1. Okay, if A is 0, A is 0, B is 0, and C is 1, what should be the output according to the theory, according to the truth table which we have created? Z1 should be 1 and Z2 should be also 1, I think. Both Z1 and Z2 should be 1. Yes. Okay. So now you can see the LEDs which are connected to Z1 and Z2. Have you noticed that the LED have started glowing? LED which was earlier off, now LED is now on. So both Z1 and Z2 are 1 in the experiment also, and we have discussed this in the theory also. So our experiment is satisfying our first logic input combination. Next step is to check for all possible logic combination. After 0, 0, we have checked for 0, 0, 0. We have checked for 0, 0, 1. Next is 0, 1, 0. 0, 1, 0 means A is 0, B is 1, and C is 0. The process to convert a logic level from 0 to 1 is just click on the red, so it will get converted to green, means click on 0, so it will get converted to 1. Now A is 0, B is 1, and C is 0. Output should be 0, 1, 0. What's the output? 0. Z1 and Z2 both should be 0. Yes, everybody agree. So LED is the LED glowing? Is the LED on? No. Our experiment is satisfying that third column of the truth table also, third row of the truth table? Yes. Okay. Next is 0, 1, 1. A is 0, B is 0, and C is 1. If you check for the truth table, output should be 1. Yes, LED is glowing, Z1 and Z2 are 1. So similarly, every logic input can be tested. So in this particular part 1 of the experiment, we have tested our basic logic gates. Like we have generated a term which is AB plus A bar C plus BC. How the term is generated? First we have generated AB, then we have generated A bar C, then we have generated BC. We have ORed it. So we have on the very if we say in a very fundamental way, we have generated all the basic logic combinations, logic gates. We have tested all the logic gates. Also we have verified the equivalence of AB plus A bar C plus BC is equal to AB plus A bar C. Now, what we notice, well, what important thing is, if we go for theory, that BC is a redundant term. Like there was no need for BC in that particular expression. AB plus A bar C plus BC is equal to AB plus A bar C. Means BC was not necessary. Unnecessary, BC was added to that expression. This is called redundant term, which you might have studied in the digital electronics theory part. Okay. I hope this particular experiment is clear to everyone. Similarly, we can go for part 2 of the experiment. Just we will have a walkthrough. We have about 5 minutes remaining. We can have a walkthrough of part 2 of the experiment. Here we need to verify AB plus A bar C is equal to A plus C into A plus B. Okay. What we need to verify is AB plus A bar C is equal to A plus C into A bar plus C, A bar plus B. So what we need to first generate is AND gate of A and B, means AND combination of A and B, so that we have generated using IC 7408 quad 2 input AND gate. Similarly, we have generated A bar C. First we have complemented A, then we have AND with C. Then also we have generated A plus C using a OR gate IC. Also we have generated A bar plus B using again a OR gate IC, and we have dot, means we have AND both A plus C and A bar C. Now again the steps are similar. First you need to have a theoretical knowledge that if A, B, C and are 0, what if A, B and C are 0, what should be the output? Yes, it should be 0. Okay. Now you go for all 1. If A, B, C all are 1, what should be the output? Just randomly checking. If A, B, C all are 1, what should be the output? AB plus A bar C. If A, B, C all are 1, what should be the output according to the theoretical one? Yes, LED is glowing. That is same to A plus C into A bar. So using this virtual lab exercise, this is almost similar what we used to do in our offline environment. Some of you might have attended digital electronics lab when we were all things were okay, and there were lab exercises in the original labs. Okay, so we used to have some ICs. You used to put them on some breadboard or some kit available, and then you used to give some logic 1, logic 0 input using some push pull switches, and you look for a LED which was connected to output. How many of you have performed digital electronics lab in an offline environment? Anybody is there? Yes, probably third sem, fourth sem students. Some would be there who have fourth sem students. How many of you have visited digital electronics lab of your college in a of yes, yes, same thing. Yes, Prakar, I think yes. So yes, we have performed exactly the same interface is being provided by virtual labs platform, and it's much more easier. It's available 24/7. You are just checking every possible combination, and most important, there is no damage for damage of IC. That could be one of the problem when in the offline environment that IC would be damaged or some issue. But here it's available 24/7. No hindrance to your academic growth. Okay, so I would like to thank IIT Bombay for this initiative to provide a platform for all of us so that we can perform all the experiments. Okay, fine. Okay. So a lot of all the students, all the participants, there are a lot of exercises available. Lot of experiments are given in under digital electronics circuit lab. Even there are a lot of other exercises given in other subjects. Just try to explore the virtual lab platform as much as you can, so that you will be much more familiar till the COVID era is going. Even after the COVID era is over, you need to perform more and more experiments. It will be greatly beneficial for you all. So with this, I would like to hand on the session to Ruchika ma'am. Ruchika ma'am, are you there?
Yes, sir.
Yeah. So now mechanical engineering department will be hosting the next session. Ma'am, it's over to you.
Okay, sir. Thank you so much.
Okay.
Okay. Very good afternoon to all of you. And I'm just sharing my screen. Okay, is it visible? Is it visible? My screen is visible to all of you?
Yes, ma'am. Yes.
Okay. So in that particular slot, we will perform some experiment related to mechanical background, mechanical program. As you all know that how to come on this page, you just search virtual lab and click on virtual lab or IIT Mumbai virtual lab, and you will get this page. And in this page, you will have different programs like electronics and communication, computer science, electrical, mechanical, chemical, civil, and all. And we will perform some experiment from mechanical background. So just click on the mechanical engineering. And after this, you will get this page in which there are some different streams or courses of mechanical engineering program. And all the experiment related to that particular course will contain in these different labs, like material response to microstructural, mechanical, thermal, and biological simulation lab, CAD lab, virtual lab on mine, mechanism and robotics lab. Okay, and there are some different kind of labs related to mechanical engineering program. So and these are the institute who designed these all experiments in virtual lab. So just go for the dynamics of machine lab, which is designed by NIT Karnataka. So just click on the dynamics of machine lab and you will have some introduction about the dynamics of machine lab. So if you study a dynamic system with the forces, then we call as the dynamics of machine. If you study kinematics as well as forces acting on the system, so this is called a dynamics of machine. So the different list of experiments in the dynamics of machine labs are, there are some kind of governors. So Proil governor, Portal, Hartnell, and balancing of multiple masses in a single plane or balancing of multiple masses in multiple planes, flywheels, different type of flywheels. So just go for the, suppose assume we want to perform an experiment related to Porter governor. So just click on this and you will get the objective or main aim of this experiment, which is to visualize the working and effect of a speed change of Porter governor through simulation. When we want to perform or doing some experiment, it is essential that you know all the basic information related to the particular experiment. So for this, we just go for the theory about the governor, what is Porter governor, what the different kind of links in the Porter governors and their arrangement. Okay, so this is the theory part which you should know before performing the experiment or simulation. So the basic learning objectives of this experiment is first, identify the parts of a Porter governor such as flywheels, spindle, links, arms, date weight, and sleeves. These are different links of this governor. So the first aim is to identify the different parts of governor. Second, explain the working and uses of Porter governor. Third, calculate the height of governor with respect of rotational speed. Second, examine the variation in the length of links, length of arms, and rotational speed of spindle of the Porter governor. And note down the minimum and maximum height of governor to its rotational speed and examine the results by plotting the graphs. So basically, what is the governor? The governor is used to regulate the speed of engine in case of varying load conditions, or basically it is used to regulate the fuel supply under the varying load condition. Suppose loading condition on the engine is increasing. Loading condition, when the loading condition is increasing, the speed is decreasing and there is need more fuel supply. And if the load condition is decreasing on the engine, the speed of the engine is increasing, and there should be cut off of some kind of amount of fuel supply so that the average speed is maintained throughout the cycle. So governor, basically governor is used to regulate the fuel supply under the varying load condition. So when we talk about the Porter governor, so Porter governor is a kind of date weight governor which is controlled by a centrifugal force. So it is come under the category of centrifugal governor, in which a centrifugal force is act on the fly balls, and because of its centrifugal forces, the balls are going outward or inward direction, which is controlled by the engine speed. So this is the basic arrangement of Porter governor. These two are the fly balls or governor balls, and these are the upper arms which are pivoted on the spindle. This is the spindle which is connected to the engine shaft with the help of bevel gear, so that when the engine shaft is rotating, the spindle is rotating with the same speed. These lower are the links. These lower are the links, and these links are connected to the sleeve. This part is known as a sleeve. And we, in case of Porter governor, we consider the weight of the sleeve. If you talk about the Watt governor, we neglect the weight of the sleeve, but in case of Porter governor, we consider the weight of the sleeve. And this sleeve is connected to the bell crank lever mechanism, which is connected to the throttle valve, which regulate the fuel supply. Okay, so in this arrangement, when the speed is increasing, suppose when the speed is increasing, the load is going down. So when the speed is increasing, the spindle is rotated with the high speed, and centrifugal force act on the balls. With the help of a spindle, the balls are also rotated, and when the balls are rotated, the kind of centrifugal forces act on the balls, which with the help of these centrifugal forces, the balls are going outward direction, and the sleeves move up, and you will get the height of the governor. So how you visualize all these things? Before this, just take a equation and formula with which you can correlate the simulation process, or you can find out the parameters from the simulation. Okay, so small m is the mass of each ball, fly balls. Capital W is the weight of each ball, that is mg, and capital M is the mass of the central load, which is on the sleeve basically, and h is the height of governor. Height of governor is basically the distance, the vertical distance measured along the spindle from the intersection of these fly balls to the pivot point. This vertical distance is called as the height of governor, and when the loading condition is changed, the height of governor is also changed. Okay, so we will calculate the this change amount in height of governor. So just go for the simulation process so that we can easily see what the changes are occurs when the number of RPMs are changes, when the mass of flywheels are changes, and when the how we can calculate the height of governor. Before this, you can go for the pre-test. Before this, you can go for the pre-test where you can try a quiz where you find how you know the basic theory about the experiment or not. So just go for the procedure. Okay, so the procedure we follow for the simulation is this kind of a procedure in which the simulation window contains the front view, top view of the governor, and a free body diagram. In this free body diagram, you can see all the forces, different forces acting on a different points or different link of the governor. And in the variable window, you can find the three variables: number of RPM, flywheel mass, and the height of the governor. Okay. And in the controls panel, you will find two kind of a window, show graph and go to experiment. When you click on the show graph, you will get a graph between the different variables. Okay, and if you go for the experiment, you will perform calculation or identify the different parts of the governor. Okay, so when you click on the right hand side of the variables, you will change the parameters like n, m, and you will get the height of governor according to the changing number of RPM and mass. And when you click show graph, you will get the graph. Okay, so for example, in this simulation window, if n, and you will this is the actual formula. Okay, n square is proportional 1 by h, number of RPMs. This formula gives the relation between the number of RPMs and the height of the governor, and according to this analytical formula, you will find the change in different parameters with the help of simulation. When you change n, when you change h, what is the graph plot, what kind of a graph you will get. So this is the graph between number of RPMs and height. So this is basically the procedure, and we just go for the simulation so that you can easily see the changes in different parameters. So this is the simulation. Okay, simulation window in which you can see front view, top view, and free body diagram. Okay, as I earlier discussed that the height of governor is the vertical distance measured along the spindle axis from the center of fly ball to the pivot point. So this h is the height of governor basically. Fc is the centrifugal force. The magnitude of Fc is mr omega square. small m is the mass of the flywheel. Okay, and this is the weight. Okay, these are the tension T1 and T2 act along the upper arms and the lower links. Okay, and W/2 is the considerable mass of the sleeve. Okay, this point D is a sleeve, and this is the governor or spindle axis. In this diagram, you can see red are the fly balls. Upper arms are pivoted at this point. Lower arms are connected to the sleeve. Okay, this spindle is connected to the engine shaft with the help of bevel gear, and the sleeve is connected to the throttle valve through bell crank lever mechanism, so that we can regulate the supply of the fuel according to varying load condition. So what is a varying load condition? Change in speed. Change in speed gives you the varying load condition. So you can change your speed with this regulating button. Okay, you can go right hand side and change the number of RPMs, and you can find the change in height of the governor. Okay, when you click on show graph, this will give you the variation between the number of RPMs and height of the governor. And make sure this variation is correlate to the analytical formula of Porter governor also. You can change the mass of the governor also, because the centrifugal force is directly depend on the mass of the flywheels. So you can also change the mass of the flywheels, and you will get the different points on the graph according to change in the mass of the flywheel. Okay, so we go for the experiment. If you go for the experiment, you will have two choices: calculation and identify parts of governor. So just go for the identify the parts of governor. Okay, these are the parts. Okay, so can you tell me what is this, what we call this link, or what we call this part? Can you tell me the name of this part? Anyone? Suppose this part is called arm. Yes, this is the arm, because this green sign gives you the correct answer. Suppose this is also arm, so this is not an arm. Okay, if I click on this and name it as a spindle, so this is not a spindle. What is this? This is the fly ball. So you can go in this window and you can identify the different parts of the governor. Okay, and in the calculation part, just go for the calculation part, see what happens. Start experiment. Okay, so in this case, there is a constant variable. The mass of the sleeve is constant in throughout the experiment. Okay, only the number of RPMs and height of governors change. If you talk about this graph shows the different height of governor at the different number of RPMs, and for that, if you want to find the mass, you can calculate with the help of analytical formula and cross check over here. So this answer gives you 4 kg mass of flywheel. Okay, if you want to reset the experiment, okay. In that case, if you want to find when the number of RPMs is 130 and mass of the flywheels is 4.5 kg, so what will be the height of the governor? So you can calculate with the help of analytical formula and also find check. So you find the height of governor 288.48 mm. So this is the simulation process in which number of RPM, mass and height of governors are the 3 variables, and you can make changes in 2 variables and find out the third variable. Okay, and you can plot the different you can plot the graphs between the different variables. Okay, so this is the one experiment, simulation experiment related to Porter governor. Now there are some courses which is common in different programs, like strength of material. Strength of material is a course which is common in civil engineering and mechanical engineering also. So just take an example of okay, just give me a second. So we take an example from strength of material lab, okay, which you will find in the civil engineering virtual lab, and which is designed by IIT Karnataka. So this is a strength of material lab. This is the introduction. We deals with the internal forces, deformation, and external forces. In case of strength of material, we find out the mechanical properties of different materials by performing different experiments, okay, different tests. And for this, the list of experiment for strength of material lab, you will find these different experiments: iso impact test, sharping impact test, kind of hardness test, okay, Brinell hardness test, weaker hardness test, tensile test, compressive test, and all. Suppose let us perform one experiment, Brinell hardness test. Okay, so you will find some basic theory of Brinell hardness test machine. With the help of this machine, you can find the hardness of material. Okay, this is the machine, and these are the different component of Brinell hardness machine. This is a hand wheel. Okay, with the help of hand wheel, you can reset your, you can set your